Hello, check. Hello.
mobile phone. Please maintain a silence. Kindly switch off your mobile phone. I request all the participants to kindly switch off your mobile phone. Please be seated. Cozy morning to one and all present here. I am S. Priyadarshini, Assistant Professor of English from Vinayaka Mission's Kirupananda Variyar Arts and Science College to host this iNEEBA 2025. Embrace the new dawn for its mark, the start for a new life. Let the adventures begin. Welcome this open arms. It's a great way to growth. It's my pleasure to start this auspicious occasion with the blessings of God. For the miracle of our time, I feel honored to welcome you all in this wonderful occasion. I wholeheartedly welcome all the respected dignitaries who have agreed to share their precious time and knowledge with us on the first day of enlightening ANRF-sponsored Indo-South Korea, Thailand 5th International Conference on Nanoscience and Nanotechnology for Energy, Environment and Biomedical Applications, jointly organized by Vinayaka Mission's Kirupananda Variyar Arts and Science College, a Constituent College of Vinayaka Mission's Research Foundation, deemed to be University, Salem, Tamil Nadu, India. A core facility center for photochemistry and nanomaterial research institute for advanced chemistry, Gyeongsang National University, South Korea, and Department of Chemical Engineering, Chulalongkorn University, Thailand, cordially inviting you all for the iNEEBA 2025. I welcome all the eminent speakers and guests from all over the country, from different walks of life. They have come here to share their knowledge and vast experience. This is the first international conference in the history of our college. Previously, we had successfully conducted 4 international conferences. At this venture, it's our delight to invite the guest of the day, the management, respected chief guests, eminent speakers, guests of honors, university officials, honorable vice chancellor, respected registrar, our principal, a dean from various institutions. enthralling head department, fascinating faculty members, and last but not least, our mesmerizing participants who are agreed to present to attend this international conference. On behalf of the institution, I offer my regards to all the dignitaries on and off the dais. Once again, I welcome you all on the delightful occasion. I also welcome the participants who have joined through online. Success is to be measured not for such by the position that one has reached in life as by the obstacle which he has overcome. A noble philanthropist and educationalist established Tirumuruga Kirupananda Variyar Tavathiru Sundara Swamigal Medical, Educational and Charitable Trust in the year of 1981 with the heavenly blessings of Dr. A. Shanmugasundaram, Founder Chancellor of Vinayaka Missions Research Foundation, deemed to be university. With the benevolence of Mrs. Annapurani Shanmugasundaram, Madam Founder Chancellor of Vinayaka Missions Research Foundation, deemed to be university. With the blessings of them, we begin this occasion. Education is the powerful weapon which can use to change the world. The circle of Vinayaka Missions Research Foundation, deemed to be University Salem. Dattosri Dr. S. Sarivanan, President of Vinayaka Missions Research Foundation. Dr. A. S. Ganesan, Chancellor of Vinayaka Missions Research Foundation, deemed to be University. Mr. N. V. Chandrasekhar, Vice President of Vinayaka Missions Research Foundation, deemed to be University. With the showered blessings of them, we begin this delightful occasion. Teamwork is the ability to work together. Let us have a small video clippings of the history of 5th International Conference, iNEEBA 2025.
invitees with a prayer song. I kindly request all to stand for a prayer song. The lighting of the lamp marks the beginning of enlightenment and dispelling of ignorance. Let the lamp symbolize the eternal light of learning and power of wisdom. The lamp burns to remind who are present of peace and positive brightness. I request all the dignitaries to lighting the lamp. Thank you, dignitaries. A guiding soul is like a lighthouse in the darkest night, shining bright to lead us. Every soul carries a spark of light that can illuminate the path to shine. Welcome to this unique platform where minds meet, ideas flourish. Together we embark on an odyssey will shape our future and strengthen our global bonds. It is none other than convener of iNEEBA-2025 and our dynamic principal of Vinayaka Mission's Kirupananda Variyar Arts and Science College. May I invite Dr. V. Anbalagan sir to deliver a welcome speech.
Very good morning to all of you. Respected chief guest, guest of honors, participants, very good morning to all. With the heavenly blessings of our founder chancellor, Dr. A. Sanmugasundaram, I wholeheartedly welcome you all for this Indo-South Korea, Thailand, 5th International Conference on Nanoscience and Nanotechnology for Energy, Environment and Biomedical Applications. So this is an iconic event of Vinayaka Mission's Kirupananda Variyar Arts and Science College, and we are conducting this 5th International Conference during the celebration of Silver Jubilee year of Vinayaka Mission's Research Foundation deemed to be university. This event is jointly organized by Vinayaka Mission's Kirupananda Variyar Arts and Science College, Gyeongsang National University, South Korea, and Chulalongkorn University, Thailand. So this iNEEBA, we are conducting fifth year. This is 5th edition of iNEEBA. First 2 editions we have conducted through online during 2001 and 2021 and 22. 3rd edition of iNEEBA we have conducted in physical mode at our VMKV Medical College. 4th edition of iNEEBA we have conducted in our VMKV Engineering College campus. So this is 5th iNEEBA we are conducting at Annapurna Engineering College. Almost we are trying to cover all the campuses within VMRF DU. So this year remarks the 5th series of iNEEBA, and the primary objective of this iNEEBA conference is now being organized for the 5th consecutive year is to foster and advance the cutting edge research in nanoscience and nanotechnology with special focus on energy, environment, sustainability and biomedical applications. Over the past editions, we have successfully conducted 4 conferences. For this purpose, we are bringing together participants from diverse backgrounds with different areas expertise for this conference. So I am proudly announced that we have published around 157 publications from Scopus indexed journals through this 4 iNEEBA conference. We definitely hope good number of publications will definitely coming from this 5th edition also. So with this small introduction about iNEEBA, I wholeheartedly welcome our Honorable Vice President of VMRF DU, Sri N.V. Chandrasekhar Sir, for accepting our invitation for this inaugural function. I wholeheartedly welcome you for this function, sir. I would also mention that 3 physical modes we have conducted this iNEEBA. Sir was the chief guest. Sir has accepted for all 3 iNEEBA series. Now I extend my warm welcome to our respected registrar sir, who has also participated in all 3 series, Professor Dr. A. Nagappan, who has accepted our invitation and for gracing this inaugural function. I wholeheartedly welcome you, sir. My special welcome goes to Professor Myang Yang Chai, who is the instrument in conducting all iNEEBAs. Whenever we approach him, definitely without any hesitation, he is accepting our invitation. He has come forward for this iNEEBA. He is very happy about this iNEEBA series. I wholeheartedly welcome you, Professor, for this iNEEBA. I also welcome our Professor Suradeep, Professor of Chemical Engineering, Chulalongkorn University, Thailand, for accepting our invitation. Previous 2 editions we have tried our level best to bring him, but unfortunately we couldn't. But this Silver Jubilee celebration, he has accepted. I wholeheartedly welcome, Professor. I also welcome Professor Dr. Tirthagiri. He is an instrument for and bridge between our VMRF and GNU. Whenever we want to contact Professor Chai, we will contact through Tirthagiri. He is a bridging between our VMRF and Gyeongsang National University. I wholeheartedly welcome Dr. Tirthagiri for this iNEEBA. I also welcome Professor Chanan from Chulalongkorn University. He is the first time coming for this iNEEBA. I wholeheartedly welcome. I also welcome Professor Chuttipang. He is also first time coming for this iNEEBA 25. I also welcome Professor Chuttipang. A special welcome to our Vanvisha. He is attending 2nd time this iNEEBA 2025. Yes, she has attended iNEEBA 23. Now she is attending iNEEBA 25. I wholeheartedly welcome you, ma'am. I also welcome Professor Dasa Pragasam, our KV Arts and Science College. I also welcome principals and directors, deans of various Constituent College of Vinayaka Missions Research Foundation deemed university. I also welcome HODs of various colleges of VMRF DU. Finally, I would like to mention that about more than 40% participants continuously attending iNEEBA 21 to 25. This is our great success. I wholeheartedly welcome all the participants from all over the nation for participating in our conference. So the conference is yours. You can utilize, you can interact with the faculty members and the professors from abroad. We have eminent speakers also along with this foreign speaker, Professor Dr. A. Pandikumar, Senior Scientist, Sikri Karaikudi, and Professor Sankarlal Gar is an editor and former principal of Holkar Science College, Indore. He is an editor of Research Journal of Biotechnology. And Dr. Kalpana, Senior Scientist, Sikri, Madras Campus. I also welcome Dr. S. Manivannan, National Institute of Technology, Trichy. I also welcome Professor Dr. S. Anandan, Scientist, ARCA, Hyderabad. And I also welcome Dr. Karunagaran, Alagappa Government College, Karaikudi. Dr. Vasanta Kumar from one of the eminent pharmaceutical company called Pfizer. I wholeheartedly welcome Dr. Aruna Kumari. She is also participating 3 times in our iNEEBA. I wholeheartedly welcome you, madam. I also welcome Dr. R.A. Kalaivani, Dean Basic Sciences, Wales University for this conference. Finally, I wholeheartedly welcome you all for this iNEEBA 2025. Thank you very much.
Thank you, sir.
Gratitude is the fairest blossom which springs from the soul. Words cannot express our gratitude for your extraordinary effort in measuring the success of our event. Now it's time to honor today's guest. Now I invite Mr. N.V. Chandru sir to honor Professor Dr. Myong Yang Koi. Once again, I invite Chandru sir to honor Professor Dr. Surdeep Khyawam. Thank you, sir. Now I invite Professor Dr. A. Nagappan, sir, to honor Dr. Suttipeng Vanapaipun. And also invite Dr. Kanan Pokraj. Sir, and also invite Nagappan sir to honor Dr. Vanvisa Limkirat. Thank you, sir. Now I invite Professor Dr. V. Anbaragan sir to honor Sri N.V. Chandrasekhar sir. Thank you, sir. Now I invite Mr. B. Dasaprakasan, Head Department of English, to honor Professor Dr. A. Nagappan, sir. And also honor Dr. J. Tirthagiri, sir. Thank you, sir.
A new chapter begins. The possibilities are endless, empowering minds, shaping futures and creating possibilities. He is a man of simplicity, elegant, and man of letters. May I request Vice President of Vinayaka Missions Research Foundation, deemed to be University, Salem. It's my esteemed pleasure to invite Sri N.V. Chandrasekhar sir to deliver a presidential address, making it possible to attend this function even though in his hectic schedule.
Respected Professor Dr. Nagappan, Registrar, Vinayaka Mission Research Foundation. Respected Guest of Honor, Professor Dr. Myong Chai from Gyeongsang National University, South Korea. Respected Guest of Honor, Professor Dr. Surapan Kirawam from Chulalongkorn University, Thailand. Respected guest speakers on the dais and off the dais. Respected university administrators of Vinayaka Mission Research Foundation. Respected Professor Dr.
Okay, thank you. Thank you. A very good morning to all. I'm really happy to be here and honored to be here. And on behalf of the Core Facilities Center for Photochemistry and Nanomaterials, the Gyeongsang National University, South Korea, I extend my warm wishes to one and all gathered today for the international conference. It gives me immense pleasure in jointly organizing Indo-South Korea, Thailand, 5th International Conference on Nanoscience and Nanotechnology for Energy, Environment, and Biomedical Applications, iNEEBA-2025, along with the Vinayaka Mission's Kirupananda, Variyar Arts and Science College, a constituent college of Vinayaka Mission's Research Foundation, deemed to be a university, Salem, and Chulalongkorn University, Thailand. The aim of the iNEEBA-2025 is to provide an effective platform for academicians, researchers, and startups and the industrial practitioners to connect, discuss, and exchange their research ideas and explore appropriate future strategies in the field of nanoscience and technology. In addition, I believe it would provide an opportunity for potential scholars to develop and enhance their research skills. Also, it will be lay on emphasis on the processing of new economical start materials and facilitate its application to the next generation of researchers. Before closing, I have to extend further thanks to Vinayaka Mission's Research Foundation, management, and Chulalongkorn University, who greatly helped in organizing this conference. I especially thank Dr. Ambulagam, principal, organizing this conference, and also Vice President and Registrar, and all the people here. And thank you so much. And it's a great warming to be a part of this conference, and I'm sure that this conference collaboration will pave a way in extending research collaborations between among three institutions and extend research support to each other. So let us join together and enjoy this conference. Thank you very much for all. Thank you.
Thank you, sir, for your continuous guiding and beacon and emphasis on the collaboration for all of us to work with dedication. Each person must live their life as a model for others. Success starts with every challenge not from the comfort zone. His early research on applying advanced mathematical tools to improve the control operation and maintenance of chemical processes, along investigation, key phenomena in industrial chemical system. Sir has published 250 peer-reviewed articles serve on editorial boards of several international journals. He is frequently invited to deliver keynote lectures at the worldwide. Now he integrates the fundamental electrochemistry, material engineering, and system-level optimization to advanced high-performance, durable, and sustainable energy storage solution for large-scale application. It's my honor to invite Dr. Surdeep Kyawam, Assistant Professor in Chemistry, Department of Chemical Engineering, Faculty of Engineering, Chulalongkorn University, Thailand, to bring the conference highlights.
So thank you very much for inviting me, for having me here. So It's my great pleasure to witness the successful of the conference by in person this time. Though, well, last year and 2 years ago, well, I delivered my talks through internet, of course. Internet is, since, well, pandemic, people used to Zoom and video conference is acceptable. But anyway, it's a great pleasure to be here in person. And well, I thank the organizer and especially, professor from Vinayaka Missions University, yeah. And one thing I love about collaboration is, you don't know where the collaboration leads to, yeah. So by oneself, of course, we can develop and improve our understanding and develop a new technology. But with collaboration with people from different backgrounds and different fields, we can further the horizon of the possibility. So I believe that this conference, it's a good place for starting collaboration in more future. Yes, thank you very much.
Thank you, sir, for being here with us, for making this conference a remarkable occasion. Coming together is a beginning. Keeping together is a progress. Working together is a success. The world is a mosaic of ideas, and together we complete the puzzles of progress. It's a memorable moment to release our international conference proceedings, iNEEBA 2025. May I request Sri N.V. Chandrasekhar, sir, to release the proceedings to Registrar Nagapan, sir.
Sir.
Be thankful for what we have. You will end up having more. If you concentrate on what you don't have, you will never ever have enough. Sir is working as a research professor, Brainful Fellow in the Department of Chemistry, Gyeongsang National University, South Korea. His current research is focused on the development of electrocatalysts from the production of energy, saving fuel and value-added chemical. Professional involvement, Dr. J. Tirthagiri as editorial board in the Bioenergy and Science of Advanced Material Journal, associate editor in Chemical Papers Journal. He has published 175 referred papers in highly impact international conference, edited 2 books for Elsevier and 1 book for RSC publishers, 20 book chapters and 4 patents, delivered several invited keynote plenary lectures at the international conference and academic institutions. Now I invite Dr. J. Tirthagiri, sir, to propose the vote of thanks.
So, good morning to all. First of all, I would like to thank the management of Vinayaka Mission and conference organizing committees, especially Professor Anbalagan, for choosing this wonderful and needful topic. Why this is the important topic, the conference topic means we know that day by day the needs for energy is keep growing along with the human population as well as industrial developments. So most of the energy demands is covered by the fossil fuels. The fossil fuels we obtaining from the natural source resources, but we don't know how long these natural resources we can get it. And another thing is these fossil fuels can in fact the toxic to environment. For example, we are using petrol and diesel engine which can emit CO2 gas which is highly toxic to the environment. So the need for the alternative resources, that was especially renewable energy resources, the people are much attracted. So we should know what is renewable energy. So if we replace petrol and diesel engine by electrical vehicle, electricity, is it called renewable energy? No. So we need to know, as a researcher or scientist, we should know how this electricity produced. That was the renewable research. So based on this topic that chosen by the organizing committee is really wonderful. I am sure that at the end of the conference, you all get to know what is the importance of clean environment and also need for the energy. And thank you all once again and wish you all success and enjoy your day. Thank you.
Thank you, sir. Now, the keynote lecture is going to start. I'll invite Dr. Deepthi Sastry, ma'am. She's going to share the session. I invite Dr. Deepthi Sastry, ma'am, on the dais.
Hello, check. Hello, check.
இது ஓபன் பண்ணிக்கங்க. Okay, ma'am.
Okay, but it is already 11:25. Till what time his session should be?
Might be around 12. He
12.
will finish around 12 to 12.
And the question and answer session will be there. So, how long? Like, they'll keep on asking, 5 minutes. Okay.
Because due to time concern, we are half an hour
Delay.
delay.
Then I can stop.
Make it, you tell, convey this, please.
Testing. Testing. Is it working? Little bit.
Little more.
Yeah, okay.
ஸ்டார்ட் பண்ண சொல்லலாமா சார்? ஸ்டார்ட் பண்ண சொல்லலாமா?
Hello. 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 Check. Hello. 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 Check. Hello. 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 Hello.
ஹலோ ஹலோ
இல்லை இல்லை மேடம் தெரியும் ஆஃப் பண்ணுவாங்க. அந்த மாதிரி ஆஃப்லேயே இருக்கும். விடுங்க, போடுங்க மூர்த்தி, சீக்கிரம் சீக்கிரம் போடுங்க மூர்த்தி. கொஞ்சம் போடுங்க, இதெல்லாம் வெளியே வச்சுக்கணும். இருக்குன்னு சொல்லி தான் ஒரு நிமிஷம் இது வச்சிருங்க.
ஹலோ ஹலோ செக். ஹலோ 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 செக்.
Good morning, everyone. I deem it a privilege to introduce the keynote speaker of iNEEBA 2025, Professor Myong-Yong Choi. Professor Myong-Yong Choi is a distinguished physical chemist with expertise in spectroscopy, laser photochemistry, and nanomaterials. He is a senior faculty member in the Department of Chemistry at Gyeongsang National University, South Korea, where he also serves as the director of the Core Facility Center for Photochemistry and Nanomaterials and is the director of the Graduate School of Molecular Material Chemistry. Professor Choi earned his MS in chemistry from the University of Idaho and his PhD from the University of North Carolina at Chapel Hill. He subsequently conducted postdoctoral research in the Faculty of Science at the University of Southern California. His research group has pioneered a variety of laser-assisted techniques for the synthesis and characterization of metal nanoparticles, alloys, nanocomposites, and coordination polymers. These efforts have significantly advanced applications in spectroscopy, chemical sensing, and catalysis. I request the audience to kindly maintain silence. Audience, we have a very erudite, distinguished speaker from another country. Can we have some respect for him, please? Kindly maintain silence in the hall. You will be inspired by his journey if you only listen to his credentials. Professor Choi and his team have expanded into laser-mediated fabrication of functional nanomaterials and biomaterials aimed at energy conversion and environmental remediation. Professor Choi has authored over 250 peer-reviewed publications in high-impact international journals, holds 15 patents, and has contributed to 2 edited books and 12 book chapters. He has also been invited to deliver numerous plenary, keynote, and invited lectures at leading international conferences and research institutions. In addition to his research accomplishments, Professor Choi has served on key administrative and advisory roles at GNU, including the Center for Laboratory Safety, the Center for Research Facilities, and as chair of the Department of Chemistry. He has also contributed to scientific advisory boards of external institutions. His contributions to science and education have been recognized through multiple awards and honors, including the Commendation Award, the KCS Sigma Aldrich Excellent Chemistry Award, the Ministry of Education's Top 50 Excellent Research Achievements, lifetime membership in the Gyeongsang Handlim Academy, and the Gyeongsang Award for Excellence in Teaching, the KCS Kim Myong-soo Award, the KCS Young Physicist Chemist Award, and the Ministry of Environment's Top 50 Environmental Technology Award. We are honored to have you with us, sir. All of you, please join me in welcoming Professor Myong Chuk. The stage is all yours, sir.
Thank you. Thank you very much for nice introduction, and thank you again for all of you here. I'm sure, you're busy, but with this 50th international conference in iNEEBA, I'd like to really have a privilege to give a speak here, even though I haven't done this, several times. And also it's being delayed, so I like to really go really fast, and then most of the research work will be given to Dr. Tita Giri, and I'll go really fast and see how it goes. And my title of this talk is laser, using a laser, we generate the nanomaterials for the hydrogen and ammonia production, so like for energy and environment. And thank you, also the Vinayaka Missions Research Foundation and Chulalongkorn University, and also on behalf of the director of eCore and then the BK21, I would really appreciate the attendance here. Before I go on, I usually start from this world map, maybe students are interested in, and we are from here, so very southern part of South Korea I came from, and flew Delhi to Goa to, here, anyway, and iNEEBA, Thailand people here, so we have 3 trilateral, the international conference every year. I really appreciate and thank for all the organizers. And here, zoom in, this is my hometown here, and so this is one of the, we have 9 provinces, and each one has one major national university. So we are the one major national university in Gyeongsang province here. And before we go on to the research topic, I'd like to introduce the my center. And here, maybe we can go for the little movie before we start. And this is a major campus we have. We have how many? We have 4 or 5 campuses. Here the Gyeongsang. So we have another 133 departments to the doctoral degree and integrated master's and doctor's degree. And we 1, 2, 3, 4, 5. Oh, actually 5 campuses, and we are in the major campus here. You can see the advertisement of GNU through the website, but this is a center advertisement. So we are working on these nanomaterials using laser systems, and so this is the center we have, and then core facility centers, and we're working on these SEMs and other instruments at the same time. Nowadays we are challenging to the aerospace materials. The materials really stable at the extreme conditions, like ultra low temperature and high propulsion, jet propulsion at high temperature, and mostly using laser systems. GNU is one of the universities specialized in aerospace, because the Korean NASA, like we call TASA, is established in my hometown, your hometown. So we are developing materials for the aerospace and also these materials at extreme conditions. Video for our facility center, and I'll briefly introduce the Jinju. Maybe you have seen this before. And this is Jinju Fortress and Jinju City. So we call this Light City because nowadays is from early October, so autumn or just like a fall starts. So more than 70,000 floating lanterns on the river, the Nam River here. And we have a festival, just like a festival here in like you see, so from October 4th, October 19th, we have a full festival floating on the Nam River here. And you maybe students know better than the K-pop demon hunters, like here. So we have drones like here on the river, and you can see lots of activities and here. So like the lanterns, all of the spread it's not good. So it's like gathered together on Nam River. So that's why I wanted to have a specialized instruments in here, the on-site experiments. So it's not spread or dispersed. We are having on-site experiments using all different the material instruments specialized for this photochemistry and nanomaterials, and especially these all specific instruments in my center. You can easily access and then characterize the materials, or otherwise we have to wait for a long time, about a month for getting other data. But it's really easier to for us to get the all data in one day. After the laser experiment, we can just step 5 steps or 10 steps. We can do XPS and XRDs and or SEMS and on XAS studies. So we can do in on-site. So these are the my lab and core facilities. All multi-spectral analysis in one floating droplets with IR, Raman, UV, and PLs, and thermal detectors and gas detectors at the same time. We can do this, so without containers, and all other instruments we have here, and so that. So my lab, the mission I wanted to have is world-class laboratory or center for energy and environment and sensors. Nowadays we are going for a little to the aerospace extreme condition materials, and we usually synthesize these nanomaterials with lights, like including lasers and solar lights, microwave and light, all kinds of sources. And then we, right after synthesizing this, we just 5 steps or 10 steps further, and we have all analysis tools on site. So for our purposes, like specialized for the photochemistry and nanomaterials, and we do surface analysis and structural analysis, for example, and all the other applications like renewable energy and the environments. These things that can be done also at the same time. Probably you have seen this before, or some of you guys. And I use a laser. Top-down approach is using a laser to use this focusing lens to the material or the surface of the metal. So it produces plasma plume, which is about 5,000 Kelvin or several gigapascal conditions, so extreme conditions. And these materials can be generated by the laser, and we call this is a laser pulse ablation in liquids, PLAL. And these are the mechanisms we've studied before. Another one is, so without this lens, so you can just shine the laser, irradiate material, all these metal ions in the solution. So we can reduce the ions to the nanomaterials, building up the single atoms into larger clusters and or nanomaterials. So we call this is a laser irradiation in liquids in the PLLI. So here are the let's see whether it works or not. Yes, the movies. And we can generate lots of gold nanoparticles without any surfactants, any other chemicals. So purely nanoparticles are formed, and this is called the non-equilibrium synthesis, and less complexity and a rapid process, and there's no byproducts coming out and eco-friendly. So we don't have to heat it up or hard conditions. Like in ambient temperature, we do this. And for very varieties of nanomaterials we generate. And this is a real-time video. And let me go through this topic. This is published in Angewandte, but I think Dr. Thithagiri will tell you more about this. And we use a CO2 laser. Instead of pulse laser, it is a continuous wave laser. It's an IR laser. So IR laser produces lots of heat. So heat thermal effect. So we can get these materials easily. So I'll just skip on this, the real part, because Dr. Thithagiri will tell you about this. All the kinds of experiments, and then electrochemistry work, zinc nitrate batteries, and also, so these things are covered because what happens is we have one stone, 3 mangoes, right? So like we generate electricity and we reduce pollutants to the ammonia, high valued chemicals, and also so we do store the energy. So this is the one we have. My second topic was using also CO2 laser, IR laser, and then we got the nickel cobalt dual single atoms onto the MAXene. So maybe you have heard of the MAX is material with these chemicals, and we can generate 2D materials by acid etching of a MAX. And so using this laser, using tryptophan as a supporter, and to dehydration processes, so we can induce these nickel and cobalt single atoms onto the 2D materials. So this is very other synthesis way. I mean, it's like a time costing, and it takes like a high temperature, and then process is much longer. But here it's 5 minutes, 10 minutes, like about 15 minutes, we can generate the nickel cobalt single atoms or dual atoms onto the surface of MAXenes. And as I said before, we have done these all characterizations in our center, XPS studies, and all of these carbon and nitrogen, nickel, cobalt. So this XPS shows, carbon and titanium peak shift or an NH intensity decrease, so indicating strong nickel coordination on MAXene via tryptophan. So this is the one we got. And so we got help from the Thailand synchrotron, and we did XAS, SAINS and XAP studies. And also, so we got this, SM studies, so that this is a single atoms onto the surface. So we used all different techniques, instruments to, confirm the existence of single atoms or dual atoms. So this is also similarly same as a nitrate reduction reactions, NO3RR, and so using these schemes, we get the nickel, dual single atoms onto the MAXene. There's a maximum ammonization rate of 1479 milligram per hour, and has the maximum efficiency at 0.5 volts. And these things are detailed, and probably Dr. Giri will tell you more about this. If you have any questions, you can ask Dr. Giri or my team members. And other things, we do have in situ Raman studies, and so we can see the in situ things, real time, what's progressing, what's evolving things. So using these techniques, so we can propose a mechanisms for this NO3RR. It's like we have adsorption onto the surface and reduction, like a deoxygenation, and then protonation, so that it produces ammonia. So that's the thing. And it's like a synchronized solution batteries. That's using this battery, we generate the, we cannot clearly see, but generate the electricity using nitrate to ammonia, and also generate the electricity here, you can see. And it's very stable, and it's on the cover image of advanced materials recently, this year. And another thing is go on to silver oxide onto the copper. It's just like nano flowers we can make, like a silver oxide nanoparticles, using about 90 millijoule pulse laser with 20 minutes. Using a 1064 nanometer wavelength, we can easily generate these nanoflowers. So, and then we use this one employed for the nitrate, NO3RR, and synchronized battery applications, pretty much similar as Angevant advanced material series. And also we do morphology studies confirmed by the FSM, and then the HRTM images too here. And also, pretty much similar, NO3RR with this scheme, and we get that in the excellent cyclic stabilities, about 10 hours, and more than this. Other things we can go up to, mostly we get the revision request is more than 200 hours, and sometimes you go up 500 hours too nowadays. So highest Faraday efficiency with a yield rate of ammonia quite high, and this is the thing similarly to the Inshu Raman and X2 XRDs. So these both confirm the intermediates or key players of these processes. So most likely what's happening is, onto the nanoflower, the copper oxide, the silver, and silver oxide become the copper and silver. And we expected actually this copper oxide nanoflowers as a support, but in this work, we found that it works as a support as well as a co-catalyst. So that's one with the DFT studies from I think it's Thai people, and so we noticed that this is the one. Actually, silver on copper shows the Inshu Raman also too. It really well matched with theoretical studies. So actually here, so this is copper, silver interface is the key player for the highest, nitrate NO3-RR performances. It's also published in the Cover Image and Advanced Functional Materials. So I go really fast, but anyway, it's almost my time is close to the end. But here is my summary of this my lab research using, as I said, using the laser, and the reaction happens at the extreme conditions. Especially we call it plasma plume state, and then go for variety of materials and apply the energy and environment and sensor systems. And if you're interested in, you can go for this the light science application. There's review papers, so you can have a look, and then just from the beginning to the end, almost you can see the whole processes of pulse laser ablations applied for this photochemistry and nanomaterials, and especially electrocatalytic applications. So I haven't tell you much about these other topics. We focusing on as here, and the electrocatalysis for this my lab research paper published in this year, and electrocatalysis. So I came from the spectroscopy too, and then photocatalysis about 10 years ago, and sensors we've been working also with a collaboration with the bio peoples too. So these are the ones you are interested in. Have a look. And this came with not with me, with my team members, and all thanks to the international collaborative researchers around the world. And I'd like to collaborate with many other distinctive researchers. And these are the people I'm working. And here's another international network from this Dr. Prasant Kamat and Dr. Professor Asok in Australia, and Eric is like a chief editor of the Environmental Chemistry Letters. And here Chulalongkorn, Dr. Suratep, Professor Suratep is here, and we have many publications together. And the synchrotron members here, now PK is here, there's Dr. Owanisar and Dr. Sutipong. So we like to collaborate many good things together. That's what the beauty of the research for. Before we closing, I'd like to mention about this is the instrument that we got for the first time in the world. I would say that because this is a commercial one, a Seagray from the USA, and what they call is a quantum leap. In Korea, we have Pohang and a third and fourth generation synchrotron radiations, and it's been scheduled for 2028, but it's delayed due to the budget. So it'll be established in 2030, the multi-purpose fourth generation of synchrotron, and here many synchrotron people here, or tile people, we work together. And now we have Jinju here, the core center. We have world first implementation of INSHU. XA is everywhere, but in INSHU, of course, cryogenic, the temperature goes down to about 4 Kelvin or 5 Kelvin. As I mentioned, our university is specialized for the aerospaces, extreme conditions. So it goes to about 4 Kelvin and also to about 1,000 Kelvin too. So this is the one we got. And so that's why we're saying that this is first in Korea in electrochemical INSHU systems. This is the first instrument we got because it can go down to about 5 Kelvin and we can heat it up to about 10,000 kelvins. So we can study further extreme conditions using INSHU techniques. So these are the ones. It's a synchrotron-like performance. Of course, it's not as much as good as the synchrotron, but if we spend much time, we can get the almost similar performances. And Sigray has some patents for these X-ray sources. So these are the ones. You see the June. So we couldn't get it from the elevator, so we took it out the cotton wool exterior. So we put it in. This is the final setup completion. So we are now getting interesting data, especially low temperature. It's really exciting to have it. So we are the CEO of Sigray, and we get the world-class instruments for the first time in the world. And we have many good data. It's like almost equal to the synchrotron quality. And so we are a core facility ICAX, and we have good collaboration as global users. And of course, synchrotron people, we can work together and develop better outputs. And we like to have a triangle collaborations my life. Also, we'll get a good paper, hopefully. So as an editor, I have also, have to advertise the Light LSA. I'm the editor of this. Please submit to this journal. This is one of Nature journals for photonics, who are doing photonics. And Eli also do photonics things, so it's Springer Nature journals. And environmental, I'm also working as associate editor and the environmental chemistry letters and other many papers. We worked together as last year, and as the editor was Applied Physics A, I think we got last year. And from my lab to the world, my lab members, they mostly go many places. If you are interested in, please contact us. Mostly from the India, and one Indonesian girl, and this is my first Sri Lanka Indian person now is in Canada Institute, and he's a PNL in North America, and he became the professor in Goa University, and also Dr. Ravi and Dr. Malati and Dr. Devi, they're all from the India, and here are I have to acknowledge my lab members, and my lab members, and these people, please follow us on Instagram or Wikipedia. And my graduate students, mostly some people know about this. And Dr. Lee became the National University, one of faculties. Dr. Min is in my department as an associate professor. And Dr. Moon is Suncheon National University from September. And my lab members from India, mostly from Tamil Nadu, here, influenced by the Dr. Tithagiri. And here, Tithagiri from Tamil Nadu, and Dr. Santir from Tamil Nadu, and Dr. JC is from Kerala, and also good state, right? Andhra Pradesh from Josh, and Balan from the Pondicherry, and mostly my graduate students. You see that Dr. Giri, recruited most people from Tamil Nadu. One Bengaluru. So please join us for the international studies who you are interested in. Okay, thank you very much for your time. Thank you. sorry, I tried to finish earlier, but it took some time. Yeah.
Thank you, sir. Thank you for your excellent talk and forward-looking presentation, especially in terms of collaboration, sir. Your talk highlighted how laser-based laser-engineered tuning of electrocatalysts can deliver precise activity and selectivity of sustainable hydrogen and ammonia production. And you also provided and shared useful information for international networking. Thank you for that, sir. And your publications in renowned journals is impressive. Congratulations. And your invitation to our audience for joining international studies is inspiring. Thank you, sir. The floor is open now for discussions. If anyone has any questions for the keynote speaker, you're welcome.
Or mostly you can ask Dr. Titagiri later on, or my webpage. There are many details. You can have a look, and then the review papers. You can have a look, and if you have any questions, please contact us. Or please, if you have any foreign studies, please contact us or Dr. Titagiri. He will help you a lot. Yeah.
Since there are no questions, we would like to close the session. Would you like to ask, sir, Dr. Tirthagiri? Sir expects you to ask a question. No. Okay, your presentation was so complete that the audience is stunned. They'll need time to process whatever you are presented. I'm sure they'll contact you through your email ID. Thank you once again, sir. Kamsam Nida.
Thank you, sir, and thank you, ma'am. I request Professor Dr. Deepthi Sastry, ma'am, Deputy Dean of Vinayaka Missions, Kirupananda Variyar Medical College, to issue the keynote lecture certificate to honor Professor Dr. Myong Yang Choi. Thank you, ma'am. I request Myong Yang Koi to honor the chairperson of the session, Dr. Deepthi Sastry, ma'am. Thank you, sir. Dear attendees, tea has been served outside of the auditorium. The tea break for 5 minutes. After 5 minutes, you reach that auditorium. After the tea break, the session will be, one session is parallelly going to be held in this auditorium, and the second session is the upstairs of the auditorium. I also invite Dr. J. Tirthagiri, Senior Scientist from Gyeongsang National University. I handed over the session to the chairperson of the keynote session.
So very good afternoon to everyone. It's my pleasure to be chairing this session, which will be delivered by Dr. Tirthagiri Jayaraman in the topic of laser-induced electrocatalyst for ammonia production. Dr. Tirthagiri Jayaraman is currently working as research professor, brain pool fellow in the Department of Chemistry, Gyeongsang National University, South Korea. His current research focused on the development of electrocatalysts for the production of energy-saving fuel and value-added chemicals. Professional involvements of Dr. Tirthagiri as editorial board in Bioengineered and Science of Advanced Materials Journal, associate editor in Chemical Papers Journal. Dr. Tirthagiri has published 190 refereed papers in high-impact international journals, edited 2 books for Elsevier and 1 book for RSC publishers, 20 book chapters and 4 patents, and delivered several invited keynote plenary lectures at international conferences and academic institutions. So it's our pleasure to have Dr. Tirthagiri Jayaraman. Sir, session is yours. Please.
Yeah, thank you, sir. Thank you for your nice introduction. So myself, Dr. Tirthagiri Jayaraman, currently working as a research professor in the Department of Chemistry, Gyeongsang National University, South Korea. So I will share some of my research experience on the title of laser-induced electrocatalyst for ammonia production. So the allotted time was very short because we are running late for the lunch. We have just 30 minutes. We need to cover 2 lectures. So I try to shorten my lecture maybe 15 to 20 minutes. They asked me to finish in 15 minutes. So as professor already introduced about our lab, laser photochemistry lab. So we shortly call it as a LP lab, laser photochemistry lab. Why we termed this name for our laboratory means because our research is mainly focused on the development of various functional material using laser. So that synthesized material can be applied for the various energy, environment, and mostly remediation works. So we have almost 30 group members, our team, under the Professor Myung Choi. So I am a part of one team leader. Our research, if you want to, introduce our lab means we mainly focus on the laser technique. The technique is like laser ablation, irradiation, and CO2 laser. So, shortly I can introduce what is the difference between the laser ablation, irradiation, and thermal irradiation by CO2 laser. So in this work, presentation, I will talk about more CO2 laser irradiation. So before that, there was a pulsed laser ablation, irradiation and deposition. There was a three technique, but we don't work on the deposition because the deposition is a solid gas-phase reaction. We can mostly synthesize a thin film. But whereas here in laser ablation in liquid, we can work mostly on the solid and liquid phase. So ablation, here we used focus lens. That means we can laser point, we can focus on the particular specific target, so that we can obtain a bulk to small, nanostructure. So in the irradiation, we don't use any lens. So the ray should be diverse. It can irradiate in any point. So here we mostly use colloidal solution to make metal salt solution. We can irradiate and produce a nanoparticles. So these are the two major techniques here in ablation and irradiation. So the thermal, the main purpose of CO2 laser is actually induce a thermal effect. So the advantage maybe we can see in the next slide. So I will cover only this work, like particularly we converted porcine blue analog into ferrite that we used for the nitrate to ammonia conversion, like nitrate waste to wealth concept. This work published in Angeventa in 2024, last year. So this is the work, synthesis procedure. Initially we synthesized the porcine blue analog using a precipitation method in a cubic shape. So this can be converted into ferrite within 3 minutes. That is the beauty of our the synthetic route, like CO2 laser thermal effect. So what researcher we generally use means calcination or thermal process or pyrolysis process. It takes like 1 day process. We need to treated on like a minimum 400 to 1000 degrees Celsius to convert any material into oxide. But another long time process, and another thing is here we can retain the cubic phase. Like if you see this cubic structure, this can be retained. So this is here we shown TEM images, and down is SEM images. We can see even after like this is a PBA and this one is a ferrite. Both can retain the cubic phase, but there is a hollow structure. So the research, if you take like TiO2, there are 5 decades still. Otherwise, as Professor Myung Choi mentioned, we can have an interaction later on this session, or you can email us, or of course you can go through our lab site to know more about research. Okay, so we have confirmed using various techniques like XPS. Yeah, when we talk about the electrochemical technique like potential region which we select. So mathematically, or if you take any graph, as we are doing a researcher in not only in the physics, chemistry or material science, all the known parameter, input parameter, it will be in the x-axis, and that the system unknown parameter are the CV machine. For example, if we take here cyclic voltammetric technique, which we gives the data will be plotted in the y-axis. So that was the unknown parameter. So when by tuning the potential, this is the input parameter, I can control it. So based on this reduction, like a negative potential and also forwardic and backwardic reaction. So for example, forwardic reaction, if you take one curve, any CV curve, if it is a forwardic curve, we can call it as a oxidation reaction. If it is a backward reaction, that is a reduction reaction. If you see like a CV, it starts from year to year, backward reaction. Like forward means from minus to positive if you direct, that was the oxidation. So it is a reduction reaction, which is having the less energy. We call it as a good system. A material, it should possess a low voltage and high current density. That material is better catalytic activity, not only in a nitrate reduction reaction, any HER, OER, or any alcohol oxidation reaction or reduction reaction, whatever the case of electrochemical reaction, if it is the best electrocatalyst, that should be a low voltage. So if voltage means energy should be very less, and also high current density, that should be a catalytic activity, I mean better catalytic activity. So here according to this curve, like copper ferrite shows the highest current density and close to the, I mean zero, like for example less potential is required. We can fix any either 10 or any current density respective potential for how much energy we require to attain a particular current. That is what our main focus here. So in this case we optimized copper ferrite is the best catalyst. Then we need to support what are the, I mean why this particular material is highly active, electrocatalytic active compared to the Prussian blue analog. That was we can support using a active site calculation, I mean electrochemical surface area calculation. There are various factors, electrochemical factor we can derive, and double layer capacitance. So here I have shown double layer capacitance plot. So for example ferrite material which has a highest capacitance 0.71 when compared to the PBA material. So higher the double layer capacitance reveals more electrocatalytic surface area. When I mean all the electrochemical application, it is a surface reaction, surface between the electrode surface and the electrolyte. So when there is a number of surface area will be higher, then the active site will be higher. When there is a more active site, that can leads to the higher efficiency, the system efficiency. So finally here is the plot of ammonium removal, nitrate removal and ammonium production. We can see like ammonium removal, when more number of nitrate removal, ammonium production will be higher, keep increasing. And when we give higher energy also, I mean higher energy means potential. When we give higher potential, the production rate was ammonia was increased. So this is the, we have a potential dependent. So all like opposite reaction, either oxidation reaction or reduction reaction is mostly potential dependent reaction. So we optimized this potential, particularly like 0.17. It shows the highest Faraday efficiency. So we can optimize the potential, which at what potential we can derive the highest efficiency. So all the, I mean even if you have a like almost a CHI machine, it is cost of 10 lakh I think or 7 lakh in India rupees. If we have one CHI machine, we can perform the reaction. But when we go for a application, whether it has to be high application or low application, if we take like one LSV curve or CDL curve, can we publish high impact factor? Means no. So we need to study what kind of reaction is going between the electrode surface. Like as I mentioned, electrochemical reaction is a surface reaction between the electrode surface and the electrolyte. So during a chemical reaction, what happening on the actual material? So there will be a active, as I mentioned, active site. So for example, the copper ferrite is actual my material, but during electrochemical reaction, it converted into oxyhydroxide in a alkaline solution. Of course, I mean simultaneously oxyhydroxide. So this can be act as a reactive site. We can call it as a reactive site or active site. So this was monitored using a in situ spectroscopy, like even of course in situ XRD and in situ FTIR we can perform in our laboratory. We are doing this, but here I have shown only in situ Raman technique, like to capture a reactive phases. So once we perform the electrochemical reaction, this ammonia can be captured. For example, we have performed the reaction in alkaline solution, 1 molar KOH. So ammonia is a gas. Gas can be dissolved in an alkaline solution. It will be as a NH3 remain. So what we do is we do reaction for 1 week, 2 weeks, prolonged reaction. Once we store all the produced ammonia in alkaline solution, then we can like acid trap method, we can heat this solution, alkaline solution. The ammonia as a gas, it can convert, it can transfer into acid. So when we pass this ammonia gas in acid, it can, for example, HCl gas, it form as a solid of ammonium chloride. For ammonia react with HCl, it form ammonium chloride as a precipitate. This precipitate we can reuse for the real application. For example, urea synthesis or ammonia as a fuel for the hydrogen fuel cell. The various real applications we can do. So that was the research we are doing at research like basic level to real application. That was the important thing in this work. So as the professor mentioned, we are focusing on the 3 application, like he mentioned like one stone, 3 mango like concept. For example, nitrate is a pollutant which can be reduced, I mean degradation or removal, and ammonia is a fuel which can produce by reduction, and simultaneously when we fabricate these as a battery, zinc nitrate battery, that can give the energy. So multi-application, 3 application aspect we are synthesizing, but still if you take like a normal lithium ion battery, the efficiency, power density is still very, very low because it is a solution based battery. But it was like recently, last 2 years only the researchers are focusing on this zinc nitrate battery, but still the research is going on. So this work was published in Angevente in 2024. This was a cover image, like our work has been accepted for cover image. And some of our recent works in 2025 we published in these journals. If you take almost all, about 25 to like, this one is about 22, this one is a material science is like 40, I think 40 in fact factor, 28, and this one is a 35 in fact factor. This one is a 17 in fact factor. So, yeah, of course, we used to focus about 10 high quality work, about 10 in fact factor. Finally, I want to acknowledge, I'm sorry that I'm trying to finish as much as earlier because there was another speaker waiting for, then this is Professor Myong Choi, he has given a talk this morning. And as he, pointed out, many are from the Tamil Nadu. Of course, there was this guy is from Bangalore, actually introduced by my collaborator, Dr. Aruna, and of course there is one more guy, I think whether he is present or not. He came, I think we have, introduced to Professor Suratip Lab. He is going to join for a PhD in Thailand. So we have introduced and recommended him. So likewise, if you are interested, you can directly either approach me or professor. You can go through just our website. You can type Myong Choi just in Google. You can get our lab page, or you can type my name so that you can go get our web page. There you can see all the works, and you can write a email your interest. If you take, for example, there will be 2 intake. One is in March and another one is in October. 2 intake throughout the Korea. So how to approach means once the professor is agreed, there will be a funding will be the 3 category. One is a professor funding he can offer from his own project, and another one is there will be a BK Brain Korea. He is actually Professor Myong Choi is director for that program in our chemistry department, so he can also place in that fellowship. There will be another scheme is like global, GKS, Global Korean Scholarship. That was the 2 mode. One is the embassy mode and directly university mode. There will be this was under Korean government to the other country nationals. So what they will offer means you can directly approach the Korean embassy in their country. Like for example, in India, there will be 3 embassy, I think. One is in Chennai and Mumbai and Delhi. So you can approach there. They will process your application, one thing. But it was very competitive. It is very rare to, success. In other thing is the government gives the quota for the university. That university gives some, the split seat to the department wise. So that was the easy way to get into in Korea. They will, of course, if you come into this GKS program, they will train you for 1 year of Korean language. So there is an advantage of learning a Korean language. Of course, they are paying everything and paying, they give salary as well as accommodation they will provide. You can learn one year of training of Korean language. Then you can go for continue your master or PhD courses. So once you learn this Korean language, it is not mandatory to be in research or in academic side. You can also place in various industrial oriented jobs. Because the morning someone asked about how to get a job in industrial in Korea. So one thing is you need to learn the language. That is the easiest way that you can come into GKS for your studies. Once you get GKS fellowship, they will train you. Because generally if you come direct PhD, or professor funding, there won't be much time to learn. Of course, it is depend on your skill or interest. If you have interest, you can speak. Like, of course, I am staying in 7 years in Korea. Still, I know only few words of Korean because no interest. But when you come as a student, you have a huge, you can have interact with all lab students, or wherever you go, you can just play in Korean, then easy to learn it. So this is the message I want to give you. Thank you for your kind attention. If you have any question, we can discuss now. Of course, otherwise, if time not permit, we can discuss later. Thank you.
Any questions? Any questions from audience? Otherwise, later also you can interact with Tirthagiri. It's
yes.
Thank you, Dr. Tirthagiri, for such a wonderful session. I think you are a lucky audience to have not only a technical lecture, also about the career opportunity. What are the career opportunities which are open with their university? He has briefed very well, especially in South Korea. But apart from that, his technical lecture, within the short time, hardly he took 17 to 20 minutes of briefing about laser photochemistry, especially with waste to wealth, with the social cost, thermal effect and synthesis of nitrate conversion to ammonia. It is such a wonderful topic and wonderful session. Thank you so much for this wonderful session.
Thank you. Thank you, sir.
Thank you.
Thank you for the nice presentation, sir. I kindly invite the chairperson of the session, Professor Dr. N. Thangadurai, sir, Additional Director of VMRF, to honor Dr. J. Tirthagiri, sir. Thank you, sir. I invite Dr. J. Tirthagiri, Senior Scientist of Gyeongsang National University, Thailand, to honor the chairperson, Dr. N. Thangadurai, sir. Thank you, sir. Now I would like to invite the chairperson of the session, Professor Dr. R.S. Sanmugasundaram, Director of Student Welfare from Vinayaka Missions Research Foundation, deemed to be University, the chairperson of the session. I would like to invite sir, and I also invite Dr. M.L. Aruna Kumari, Head Department of Chemistry, the Oxford College of Science, Bangalore, India. The session is over to you, sir.
In the name of Lord Vinayaka. Good afternoon to one and all. It's my honor to chair this session, this international conference. The topic of electrochemical perspective of 2D materials, under the chief of Aruna Kumari. Dr. M.L. Aruna Kumari pursued her bachelor degree in chemistry from Tumkur University, Tumkur in 2009, and master degree in organic chemistry from Kevala University, Shimoga in 2011. She received her doctoral degree from Bangalore University, Bangalore in 2017. She visited Core Facility Center for Photochemistry and Nanomaterials Department of Chemistry, Gyeongsang National University, Jeju, South Korea, from 10th June to 10th July 2024, and 29th June to 10th September 2023. Her research interest spans a broad spectrum of photochemistry involving energy, environmental, and materials chemistry fields. She has authored more than 25 research articles in international peer-reviewed journals and has authored several review articles and book chapters of scientific repute. She has been reviewer in over 10 international peer-reviewed journals of high impact factors. She has delivered several invited lectures across in India and abroad. Her H index is 17 and I-10 index of 20. Her count research interest includes the synthesis of metal oxides and its organic, inorganic hybrids for energy and environmental applications, photocatalytic organic transformations, and developing advanced oxidation process, including Fenton and photo-Fenton process. She is currently serving as a professor and head at Department of Chemistry, the Oxford College of Science, Bangalore, India. Ma'am, now the session is yours.
Thank you for the introduction, sir. Before starting the session, may I know how many graduate students are here? Just raise your hand. Graduate, BSc, BTech, Masters, Research Scholars? Okay. So if we know the audience, for us it will be easier to deliver the lecture. If not, okay, so it will be a little difficult. So today my topic is on electrochemical perspective of 2D materials. So let me tell first why I selected this topic. So this topic basically I chosen because we usually see more work on electrochemistry, and there are per month at least nearly 1,000 research articles will come over on electrochemistry. It might be in the water, electrochemical water splitting, or electrolyzer, or battery, or somewhere, so on and so forth. So many electrochemical related works we see, and everything includes 2D material. And when we see that articles of a lower impact factor and a higher impact factor both, we see a slight variation in the articles. Particularly for myself, when I see the articles, I feel there are something lagging in the basic understanding of a 2D material. So I just want to, since most of the audience are starting their career over research, so I thought this is a better platform to explain little bit about 2D materials, because any electrochemistry modifications we do, basically it has to be on the 2D material. We coat the 2D material, and upon that we do some modification. So they are the most electron transport pathway. So we need to understand that better way. So today it's all about the 2D electrochemical materials. So first let us know what is 2D material. So it is, in a simple way I can tell, in a chemical way if I want to tell, it is on about the electron moment. If I want to tell in a physics perspective, it is all about the dimension, because it is a quantum based thing. So quantum physics also we have, quantum chemistry also we have. So when it comes to physics, they talk about the direction. When it comes to chemistry, they talk about the electron moment. So here in the 3D material, electron flow will be there in all the three directions, and the size of a nanomaterial, for example, growth we control in no dimension. I mean, in none of the way we are not going to control the nano dimension. As we know, nano plays a very important role. When it comes to 1D confinement, or nothing but the 2D material, so here what will happen, electron, here the electron flow will be in, I mean, it is a one dimension thickness. I mean, we control the growth of a material in one dimension, so that, for example, if this is a thing, so the size matters a lot for an electron flow. So when it comes to nanomaterial, we should look in the form of a 2D materials also. We can prepare a 2D both. So when it has to be, these are the different kind of materials which we usually use in
electrochemistry. So recently there is a new topic is on elemental 2D materials. It is not exactly recently, but mostly elemental 2D materials is started from the graphene. So we all know that graphene is made up of one material, one element, that is carbon. So the carbon is joined together to give us a different varieties of graphene with the different allotropes, and the graphene oxide, reduced graphene oxide, all these things, and even they started working on the graphene also. So this is a basic step for the elemental 2D material. After the carbon, all these P-block elements, most of the P-block elements have been used as a 2D material, have been used as a elemental 2D material, and this is how the graph is there. First we discover the graphene, then phosphine, then borophene, antimonine, and like this arsenine. So all these 2D materials are already came into the picture, and they're using in wide varieties of electrochemical perspective or electrochemical application. So among this, what we have to see major is every 2D material may have, elemental 2D material will have different allotrope. We all know about allotropic form. So various allotropic forms will be there. What is exactly mean by allotropic form? How the way of arrangement of those elements, the carbon, how it is arranged, or they may be arranged in the layer. So when they are arranging in a layer, they may be in the zigzag motion, or they may be in the hexagonal or alpha form, beta form, like this. So many varieties will be there. So all these allotropes are good electrocatalysts? No, definitely not. Some of them will work as a good electrocatalyst, some of them are not good electrocatalysts. So how to choose? What basic property we need to look into that. So when it comes to 2D first, it is like a 2D material. In the 2D material, we have to see the allotropes. In the allotrope, which is suitable, which conduct the electricity, that we need to look into it. So whenever you are referring a paper, first you see the 2D, then its allotrope, and that allotrope is a good electron carrier or not, or conductor or not. All these parameters we need to see. So next, for example, if I want to tell, if I take a carbon major is graphene, graphidine, and amorphous carbon. So many allotropes are there. But in that, we usually use edge site, defects, all these parameters matters. See, we prepare a 2D material, but in that, there are so many defects will be there. You might have heard about the Franklin defect, Schottky defect, all these things in your 11th and 12th. Just like that, here and there, some element missing is there. So due to that defect, you all learned, right? Sodium crystal, NaCl, this one in your 12th. So there, some element will be missing. So when that is missing, that can trap an electron. That means from the electrode, you are giving current, you are giving electricity. The electron has to transport. When the electron is transporting, you have a vacancy over there. So some atom is missing. So definitely electron will go and stick that. Then is it a good carrier of an electron? No, it's a bad carrier. So all these defects and the extent of defect, how much extent of defects you have, all these basic work we have to do before starting the application. Okay, so like this, not only defect, there are various other kind of things also we need to look. For example, we have to see about the stability of it, we have to see about the degradation of the 2D material, sensitivity of the 2D material, toxicity of the 2D material based on the what work you are going to do. All these things we need to look before choosing our 2D material. And recently, there's a well-known topic is coming up called methylene, which we are working on it with South Korean collaboration. So there, usually we have a magazine. Magazine is what? One layer of metal will be there. X is a some P-block element. Some P-block element. In the P-block we have so many aluminum, all these things. So some P-block element will be there. So transition metal and the P-block element, they form a layers together. Alternative layers. So one metal layer, one P-block element layer, like this layer by layer they have been arranged. So what we usually do, we exfoliate. We will just tear it off from layers to layer by giving some energy. So when we exfoliate, we can separate the metal layer, we can even separate the X layer, P block layer. So simultaneously we can generate this. So what is the advantage of this? When we separate, we have one element itself. So that one element property, when we mix two, there will be some property mismatch, or property may reduce. If we have two things to control, it will be difficult for us. If we have only one thing to control, it will be easily we can control. So that is how we decide, based on the application, we can generate the metallines over there. So this is recently they have done. So they have taken this magazine, which is titanium and gold base. So what exactly they have done there? They have separated the titanium, and carbon is escaped as a carbon dioxide, and they have made only two-dimensional gold. So as we all know, metals are good conductors of electricity. So they conduct the electricity, and better conductance we will get, so that the better electrochemical activity. And this is a simple example how they have done. And coming to this metaline, so you can see the metaline started from 2007 onwards, but still there is not much work over there. So if anyone want to focus, they can focus on this metaline. So metaline is just by taking any metal oxides or metal sulfoselenides or metal selenides or whatever, we can just we need to do etching over there. So when we do that etching, we can get that separate layers. So for that etching, we can use the physical method, we can use chemical method, and there are so many energy giving. By giving certain energy, we need to separate it out. Any one we can choose. And next to this, transition metal dichalcogen. So here what they exactly use is a transition metal and followed by this, any one of this chalcogen. So there also it is similar to that. So here one layer of metal, two layers of that sulfur or selenium, or so that will have a van der Waals interaction, and that is how they have stacked one above the other. And why I am telling this? So when it comes to this, we have to see here also we get wide varieties of allotropes. So what allotropes we have to use? For example, we take a precursor of metal and chalcogen, we make a bulk. Then from the bulk, we exfoliate it to make it into layer. So once we make it as a layer, it will give us two different kinds of phase. One is tetragonal, another one is hexagonal phase. So among this, all are good for electroconductance or all are good for electrochemistry material? Definitely not. It will vary from which metal you have taken, which chalcogen you have selected. Everything matters a lot for us here. So thus I want to explain which phase we need to choose based on what thing we are supposed to choose. So as you all know, one octahedral, one tetragonal phase, all these things you might have learned in your graduates or undergraduate. So that particular time when we are learning about the octagonal or trigonal, prismatic and all these things, so there you have studied about electrochemical electrochemical series, hybridization, all these words you might have learned. So let me take into that level now. So now I'm going from this to that particular level. So now, what are this phase, what makes this phase, and how it changes its electronic property. So when we are choosing, we need to take care of all these things. So now we all know the crystal field theory. So CFT we usually call metal bind with the ligand, and it is going to form octagonal, tetrahedral, various wide varieties of phases. So that particular time when the crystal field theory or when the phase is creating, we are going to have a d orbital of 5 different energy level. They will arrange into T2G and EG, all this thing, they will arrange. So when, basically splitting of a d orbital will happen. So when this is happening, it is based on the spectrochemical series. That means which ligand is approaching. Based on which ligand is approaching, based on that what will happen, that energy changes will happen. So previously we are talking about metal chalcogen. So metal, D block metal, X will come. From once the X will come, how they will divide. So it depends on what X will come to us, what X will come and how it is going to bond. So for example, when it comes to trigonal prismatic phase, so here the d orbital is going to split into A, E prime and E double prime. When it comes to octagonal, it's split into EG and T2G. So you can see here we have a 3 energy level, here we have 2 energy level. So when we see the band structure of it, so here what will happen, the 3 energy level will be there, but the transition of electron will happen from A to E, and here transition will happen from T2G to EG. So for us, in a band structure, if a metal has, if the electron has to transfer, the major key path or electron transport is basically depending on this band gap. So that band gap will vary from allotrope to allotrope. So when you are choosing it 2D, you have to also particular about the allotrope, which allotrope you are seeing, what is the band gap of it, all these things we need to consider. So this is how, for this particular purpose, they usually use a Kettler triangle. So here what exactly will happen, the electronegativity, for example, we may have fixed one metal over here, but if I keep on changing this sulfur, selenium and telluride, if I keep on changing, its property will change from metallic to covalent or covalent to ionic, so it will be keep on changing. If it is a ionic, it will easily dissociate, we cannot use it, and if it is a covalent, single bond. So transport might be little hinder, but if it is having a metallic nature, it will be a good conductor of electricity. So this depends on what? It depends on the electronegativity. So they have correlated, and there is a, in online, if you give the Kettler triangle calculation, they will give metal and then this element you need to give. So it will show you where it is locating. It is in between this or where, what kind of nature it will give. It is already available. You can have a look of it. And this one I want to explain. So it is basically, if you change the metal also, this what will happen, this band gap will change. So we will have a metallic nature or semiconductor or semi-metal nature. We may get wide varieties of band structure based on our choice of an element. So example, if I want to take, this is a niobium selenide, this is molybdenum selenide. So here the difference is the metal, but that metal will be in its +4 oxidation state. So this will act as a metal, whereas this will act as an insulator. So based on this, we need to choose our material what we want. And recently, similarly, they have started on M-beam. So instead of X, they have used the boron. So they just do etching and all these things. And based on this, lots of work is also going on. So we can even easily develop the M-beam, and M-beam also have a various allotropic form. So we need to choose that and we need to decide. And what are the synthetic strategies we usually use? As I already mentioned, mechanical, ultrasonic, electrochemical exfoliation, solid by melting, plasma assisted, molecular beam, all these wide varieties of strategies we usually use to develop a 2D material. And we, after looking into all these things, we have done a survey and then we prepare a material. We use various strategies to prepare, based on that we may get some disorders. It is not always flat or it is not always completely packed. How much ever we have taken care, there will be a disorder. So that extent of disorders we need to check. So whether the strain or surface roughness, all these things matters a lot. When we are based on the disorder, we need to choose our application. Okay, so next one, what are the important parameters we need to consider? Stability, electrochemical stability, mechanical stability, band structures, density of a state from computational chemistry we need to calculate, work function, electron transport, which is nothing but the conductance, active sites, all these parameters, what and all mentioned here, we need to look into it. Important parameters to be considered, a 2D material has an electrocatalyst. And for this particular things, which technique we usually use. So for this we use ECD, and for this particular work function, all this calculation we usually use yields and UPS, and for the surface analysis and all these things we usually use XRD, Raman and XPS. And these are the, by these instrumentations we need to control, we need to measure all these things. And this is all the timeline, how it is going on. And this is all the future perspective. Now 2D material is well established, but still they wanted to work even more. So that is on van der Waals interaction. So they are making a 2D layer and they want to interact with the Walden interaction layer. So one 2D material I'll make, another 2D material, then I want to hold it with the van der Waals interaction. This is what the trend is going on. I mean, like now they wanted to merge two 2D material at a time. So this is the future perspective which is going on, and very importantly, now the recent trend is going on metastable state of a 2D material. That means higher formation energy. So here, when we wanted to do a metastable 2D material, so here they usually exhibit high free energy over there. So that high free energy will be utilized for various electrochemical perspective. And this is all about my presentation. I hope you understand a bit of it at least. Thank you. If you have any question, you can ask. I hope no questions.
Any question?
Okay. So you should work on it first and then you should give it, because when we take a feedback in the from Karnataka Chemistry Faculty Association, the students are telling jobs are not there. That's why we are not. Jobs are there, but companies are not taking you because you are not skilled enough. So you should do all these internships and all these things, and you need to do extra courses to getting, even though software students are, even though they are having their degree, they are also doing some side course, right, to get a job. The same thing even you should do. And please encourage more basic science. Please encourage your juniors or someone, don't tell them chemistry stuff. Chemistry is interesting, you tell instead of that. Or pharmaceutical is interesting, you tell. Okay, this is all a small request from my end. Thank you. I think this is a better platform to tell all those things.
Ma'am, actually I would like to update these things. It's a common phenomenon. Normally, every decade, engineering and science is opposite. When the engineering comes up, defaultly science goes down.
So,
when
but in
comes out, it's like a circle.
But in engineering also, only AI and machine learning, sir. Not other.
Yeah, it's no. Before that, in 2K, computer science also comes up like that. 2K problem like this, because I experienced it for past 2 decades. The scenario comes like. But I am assured that definitely one day it comes, your dreams will come true.
Thank you, sir.
Okay. And on behalf of the organizing committee of this conference, it's my great privilege to extend our grateful gratitude to our esteemed speaker, Dr. M.L. Aruna Kumari, for enlightening sessions, electrochemical perspective of 2D materials. Your presentation has given us deep insights into the fascinating electrobehavioral of parameters and characteristics of atomically thin 2D materials, their role in their energy conversions, and the promising futures they held in sustainable technologies. We are truly honored to have the opportunity to learn from your expertise and significant contribution to the field. Thank you once again, Dr. M.L. Aruna Kumari, for gracing the conference with your presence and sharing the opportunity of these fields. So thank you once again. I look you with us. We look forward to your continued cooperations and inspirations from your future endeavors. Thank you, ma'am. Thank you so much.
Thank you. Thank you for the nice presentation, ma'am. I cordially invite the chairperson of the session, Dr. R.S. Shanmugasundaram, sir, to honor Dr. M.L. Aruna Kumari. Thank you, sir. I would like to call Dr. M.L. Aruna Kumari to honor the chairperson of the session. Thank you, ma'am. Dear Dear attendees and participants, lunch has been served outside of the auditorium. Kindly join the lunch. The session will begin at sharply 1:50 p.m. I'll repeat. Dear attendees and participants, lunch has been served outside of the auditorium. Kindly join the lunch. The session will begin at 1:50 p.m. sharply. Professor Dr. B. Jaikar, Director Clinic Trials from Vinayaka Missions Research Foundation, deemed to be university. I also invite Dr. A. Pandikumar, Senior Scientist of CSIR Central Electrochemical Research Institute, Karaikudi. Sir, over to you, sir. I invite Dr. A. Pandikumar, Senior Scientist, CSR Central Electrochemical Research Institute, Karaikudi, invited to occupy the seat, sir.
Good afternoon to all. So now we are in afternoon session of iNEEBA-2025. So now the topic on the title is Photoelectrolytic Water Splitting, a journey from lab scale to prototype. So the lecture will be going to deliver by Dr. Alagarsamy Pandikumar. I feel proud in introducing Dr. Alagarsamy Pandikumar to you. He is currently working as a principal scientist in CSIR Central Electrochemical Research Institute, Karaikudi. He obtained his PhD in chemistry in 2014 from Madurai Kamaraj University. He successfully completed his postdoctoral fellowship tenure, that is 2014 to 2016, at University of Malaya, Malaysia, under a high impact research grant. He is the top 2% of scientists listed in the world database released by Stanford University, US in 2024. Moreover, he is recognized as the world's top 2 scientist in the single year category and also in the career achievement category. He has continuously achieved this record for the last 5 years from 2020 to 2024. Further, he has awarded RIAC affiliate member by Royal Society of Chemistry, UK in 2021. Recently, he has received the prestigious Young Scientist Award for 2023, that is Saraswati Srinivasan Prize, from the Academy of Science, Chennai, Tamil Nadu, for his pioneering contribution to solar energy conversion. Recently, he has been elected as Fellow of the Academy of Science, Chennai, Tamil Nadu. In addition, he is holding an Associate Professor position at Faculty of Chemical Sciences, Academy of Scientific and Innovative Research, Ghaziabad. Established with the institution of national importance by an Act of Parliament in 2010, he is a life member of Society for Advancement of Electrochemical Science and Technology. His current research involves the development of novel functional materials for photocatalysis, photoelectrocatalysis, dye-sensitized solar cells, perovskite solar cells, and water splitting applications. His research outcomes were documented in 160 peer-reviewed journals, including 14 review articles, and also have 9,980 citations with the H index of 61. He secured full funded project worth of more than 5 crores from DST, CSIR, CERB, etc. Currently, he has completed 4 PhD candidates and 6 is going on. On another side, he served as a guest editor for special issue in Material Focus Journal, Applied Surface Science Advances, and edited 21 books, 4 PhD students, 2 postdoctorals, and 14 INSA Summer Research Fellows, 12 masters, 12 B.Tech students successfully completed their tenure under his supervision. Currently, he is mentoring 6 PhD students, 2 postdoctorals, 2 INSA summer fellows, 2 masters, 7 B.Tech students, 5 project associations in his research area. So with this, I request Dr. Alagar Pandikumar to deliver his speech.
Thank you, sir. Thank you for your nice introduction. So I have chosen the topic photoelectrocatalytic water splitting, a journey from lab scale to prototype. So why I particularly chosen this particular topic? Because now our government is talking about e-mobility. For that, normally the e-mobility is based on the plug-in type electric vehicle, but in future it is expected to dominated by that fuel cell based vehicles. For that, the feedstock is a hydrogen. So for producing the hydrogen, we need a green energy production technology. For that, our government is announced a national green hydrogen mission. So this photoelectrochemical water splitting is also one of the technique for producing the green hydrogen. But so far, what are the research on this photoelectrochemical water splitting only end up with the lab scale, at least we call it as a TRL level 3. But we have just worked and moved forward and we have developed the prototype device. So I just want to share that what are the activities we are working on this photoelectrochemical water splitting and how we are moving from lab scale to prototype. So due to time limitation, I am just skipping the introduction about my research institute. So this is my research group. So here I am mainly going to talk about the hydrogen. So the hydrogen is alternative to fossil fuel. So it has that high energy density of 140 megajoules per kilogram. So it is a clean fuel. It can easily produced from water. It will not pollute the environment. Okay. So you just take a water, you can break into hydrogen and oxygen. So this is called, we call it as a green hydrogen. As well as it has several advantages. It's like it has high energy conversion efficiency. Then high production, it can easily produce from water without any emission. Then it is a earth abundant. You can easily store it in different forms like a gaseous form, liquid form or solid form. So it has that long distance transportation capability. So based on the production method, the hydrogen having different color code. So normally the hydrogen is produced from coal and natural gases. So while you are producing the hydrogen from coal and natural gas, it will emit the carbon dioxide to the environment. So the emitted carbon dioxide that can be captured and stored or converted into value-added product, we call it as a gray hydrogen or black or brown hydrogen. Suppose, blue hydrogen. Suppose if you are directly emit to the environment, it is called a gray hydrogen and black or brown hydrogen. Suppose if you are doing electrolysis of water for producing the hydrogen, for that you are using the electricity source that is produced from that nuclear power, it will create that nuclear waste. So we call it as the pink hydrogen. Then if you are using renewable energy like wind energy or solar energy, so it will use it for the electrolysis process, then it will release that oxygen as a byproduct. Finally, we call it as a green hydrogen. So these are the color code for the hydrogen. So this is the e-vehicle. So this e-vehicle is mainly based on the fuel cell vehicle. So you just look at this. This is the cross-sectional image of this fuel cell vehicle. So this fuel cell vehicle, it contains hydrogen storage tank and a battery unit and the fuel cell stack and the boost converter, power control unit and a specially designed membrane. It will allow only oxygen from the environment. Once you ignite the vehicle, what happens? The hydrogen from the hydrogen storage tank, it reaches the fuel cell stack and the oxygen from the environment, it will reaches the fuel cell. So you just look at this, the hydrogen, it will, once it reaches that the electrode, so it is release that electron and it produces that proton. So the proton can be combined with the oxygen and it produces electricity and it releases the water as a byproduct. So it is a greener product. So I think here majority of the students from the undergraduate, right? So all of them graduate or undergraduate? undergraduate. So for your better understanding, I will just show a small video. What you have seen in the previous slide. So it is very simple. It contains the hydrogen storage tank, the fuel cell stack, and the boost converter, and the electric motor. Then there is a power control unit. Once you bring the vehicle, so there is a merit of this particular fuel cell vehicle. So for a battery operated vehicle, you need at least 2 hours for charging. So it is as like filling a petrol. You can just fill a 5 kg of hydrogen within 5 to 6 minutes. That is the another advantage. You may understand the working principle of this fuel cell vehicle. So here, if you are using that hydrogen as a feedstock, that is the fuel. So the byproduct, that is water, that will be discharged to the environment. So it will not make any pollution to the environment. So this is what the merit of this particular e-vehicle. This is the positive side of this e-vehicle. However, it has some the negative side also. So you just look at this. So the hydrogen is highly explosive. So there is a one incident happened in Japan. So there is a one car got accident. So that time the hydrogen storage tank got exploded. Immediately it catches fire. So another incident in Norway. This is the hydrogen filling station. Improper handling of hydrogen. This hydrogen fueling station got exploded. So the hydrogen storage is crucial. So that the people are working on the hydrogen storage aspect. So they have introduced layer by layer structure of different chemical, finally come out with the excellent hydrogen storage tank. You just to look at this. So if you are going to buy a car, they will give a rating, 3 star, 4 star, 5 star. It's based on the crash test. So they have conducted the crash test. So the hydrogen storage tank doesn't get explode. So it got that only physically damaged. Okay. So you may ask that, so any technology is available or invented in abroad, so it will take at least 10 years or 15 years to reach India. So you may ask when we will get a technology. So our CSCR Sikri, especially madam is coming from CSCR Sikri, Chennai campus. So there they have developed this fuel cell with the available materials from the India. So they have transferred the technology. So this is the zero emission fuel cell bus. Further, they have extended the technology transfer to that marine metro. So usually this marine metro previously powered by plug-in type e-vehicle. So now it is a hydrogen powered marine metro. So it is available in Cochin. So our Prime Minister last time flagged off this particular marine metro in Cochin. So now you just imagine that if it is the fuel cell based vehicle is enter into the market, then what is that hydrogen demand? Because if you are convert everything from the fossil fuel based to fuel cell vehicle, then you need to fuel the hydrogen. Okay, so that time, especially as per the Paris Agreement 2050, we are going to achieve the net zero carbon emission. So that time 540 million metric ton of hydrogen is required. So for that, what are the technologies available for production of the hydrogen? Especially the hydrogen is available in the market is based on the blue hydrogen and gray hydrogen that has that high TRL level. Especially the electrolysis process, especially the polymer electrolyte membrane based electrolysis and alkaline electrolysis, that is just reached the matured state. But while using the sunlight for producing the hydrogen, that is still in infant stage. So we have to utilize the sunlight. Why? Because India is a sunlight abundant country. So by using the sunlight, we have to produce the hydrogen. So what are the available reports? That is in the lab scale, that is still in the infant stage. So we have to put the effort in the material design as well as the device architecture. So we have to bring up this TRL level to further category. So for that, our Prime Minister announced a National Green Hydrogen Mission. So the objective of this particular mission, India to become a global hub for green hydrogen production and export. So this is proposed in the year 2021. So in 2023, our Union Cabinet approved the National Green Hydrogen Mission, and they have sanctioned approximately 20,000 crores for following activity. So these are the expected deliverables by 2030. So we have to increase that the green hydrogen production capacity up to 5 million metric ton. We have to improve that the electrolyzer capacity 100 gigawatt. So we are utilizing this renewable source for producing the green hydrogen. So the rest of the energy connected to the grid, in that way 125 gigawatt energy we can increase the renewable energy sources. So this is the direct benefit. So other than that, if you are using the fuel cell vehicle, we no need to go for the hydrogen, petrol or diesel. So in that way, we can stop the import of crude oil, 1 lakh crores worth. As well as per the Paris Agreement, 50 million metric ton of CO2 emission we can minimize. Then it will create 6 lakh job opportunity and 8 lakhs crores corporate investment. So these are the indirect deliverable from this National Green Hydrogen Mission. So now how we can produce the hydrogen from the sunlight? You just take a semiconductor, put it into the water, exposed to the sunlight. You can see the bubbles. So the bubbles, it's nothing but the hydrogen and oxygen. So you just look at this. This is simple equation, but it involves two different reactions. One is a hydrogen evolution reaction, another one is a oxygen evolution reaction. So this oxygen evolution reaction is the rate determining step. Okay. So how this semiconductor can produce the hydrogen by using the sunlight? You just look at this. This is the semiconductor. It contains valence band and the conduction band. So once it is exposed to the sunlight, what happens? This valence band electron is promoted here, and the holes oxidize the water and produce oxygen here, and also it produces proton. This proton move to the conduction band and accept the electron, and you can able to get the hydrogen here. Okay. So this is what we call it as a green hydrogen by using the sunlight. Okay, so, but the previous case you will get the mixed state of hydrogen and oxygen. So, it involves further gas separation process. Further, there is another process, we call it as a photoelectrochemical method. Here also we are using the same semiconductor, but it is in 2 compartment cell. So, here it is separated by the proton exchange membrane. After oxidation of water, the oxygen collected separately and the proton passed through the proton exchange membrane. Finally, you will get a hydrogen here. So, it is in a separated form. So, normally the semiconductor is a 2 type, P type and N-type. If we take a N-type semiconductor, it oxidizes it acts as a photonode, it will use it for oxidation of water. If it is a P-type, it will use it to reduce the water to produce hydrogen. If it is both a P-type and the N-type, you can use it as a tandem cell. So, if you are starting your career in a photoelectrochemical water splitting for green hydrogen production, you have to consider these 4 aspects. One is suitable optical properties. So, normally the solar spectrum having that UV light, visible light, then IR radiation. So, IR radiation will create a thermal energy, UV light only 6%. So, that means 46% visible light available in the solar spectrum. So, you have to design a catalyst that can harvest the visible light photon. Then again suitable band edge alignment. So, as already explained in the previous mechanism, the conduction band and the valence band should be above and below the hydrogen and oxygen evolution potential. The third one is charge separation and transport. So, it seems once you expose the semiconductor to the sunlight, it immediately undergoes charge separation and it will oxidize the water. So, that means the charge transfer kinetics will be very rapid. Then finally the stability. So, if the material is stable, so that you can go for, you can talk about that the commercialization and you can try to move that next TRL level. So, you have to consider this aspect. So, in our interest, the bismuth based material, why? Because this bismuth based material has several advantages, because the valence band is more positive than the oxygen evolution potential. So, it will make that the water oxidation kinetics is more facile. So, that is why our interest. But however, if you are taking that the pristine material, what happens? It suffers from the charge recombination process. So, for that we can adopt different strategies: component adjustment, surface modification, morphological control, heterojunction. So, our interest forming the heterojunction. Why? Because you just look at this, if you take a single semiconductor, due to the Coulombic force, the electron and the holes will be recombined. So, as a result, it is a net result will be 0. So, suppose if you are adding another semiconductor, you just look at this picture, the same thing I am adopting here. So, the electron and holes will be spatially separated and moving in the opposite direction. So, this is what. So, normally the heterojunction can be classified into 3 types. One is a type 1, type 2, type 3 based on this valence band and the conduction band position. And also if you have that P-type and N-type semiconductor, you can form a PN heterojunction. It will also, the electrons always step down and the holes will also step up. Okay. Other than this, you want to do the reverse reaction. You want to step up the electron and step down the hole. You can adopt a jet scheme heterojunction mechanism. So, here there is a 2 type, mediator based jet scheme and mediator free jet scheme. Okay. So, I will give one example what we have done in our lab, because there is a plenty of catalysts that will be used for photoelectrocatalytic water splitting, especially metal oxide, metal nitrate and metal chalcogenase. Okay. So, actually I give one example for the PN heterojunction. So, we have developed this bismuth benedict based heterojunction through the electrochemical deposition method. For that we have taken the bismuth precursor and we have done the electrochemical deposition. Then vanadilyl precursor we have added on the surface. Finally, it is subject to the calcination process. Then we come out with the bismuth electrode. Further, we have deposited the copper oxide over this surface. Then after calcination, we got the heterojunction. Then we have done the XRD analysis. So, this is that only bismuth vanadate. Then after deposition of copper oxide, you can clearly see that the signature peak for that copper oxide that clearly indicates that good crystalline properties of this fabricated material. Then we have done the morphological studies through the FECM analysis. This is the pristine bismuth vanadate. This is after forming the heterojunction. So, to further confirm that the elemental present in that electrode, so we have done the elemental mapping. So, it shows that bismuth, vanadium, oxygen and copper. Then we have performed the XPS analysis to confirm that presence of the formation of heterojunction. So after deposition of copper oxide, there is a shift in the binding energy for both states. So it shows that the shifting in the binding energy causes the formation of heterojunction between the two interface. So that is clearly reveals. Then we have done that UV visible absorption spectra. So this shows that bismuth vanadate shows that there is a less absorption in the visible region. After deposition of this copper oxide over this surface, the visible light absorption got enhanced. So the band gap value we have calculated by adopting the Tox plot method. Then we have used the electrode for that photoelectrochemical water splitting. So in the absence of sunlight, you can see that there is a poor response, there is no current. Once we expose to the sunlight, the photocurrent got enhanced. So we have choped the illumination for check that the charge injection efficiency. So it shows the rise and fall in the photocurrents are highly stable and reproducible. So it seems we got that twofold enhancement in the photoelectrochemical water splitting performance. Then we have checked that the surface recombination process by adopting that the sacrificial agent. So it seems that after adding this sacrificial agent, the pristine electrode shows that 24% efficiency and the heterojunction shows 41.5% efficiency. Then we want to propose the mechanism to prove that the PN heterojunction. We have done that XPS UPS analysis, valence band spectra. We calculated the valence band maximum and we did this Schottky analysis for calculating the Fermi energy level. Finally, we have arrived this band position for the both semiconductors. This is before contact. After the contact, this Fermi level undergo equilibration. Finally, we have proposed that the PN heterojunction mechanism. This will oxidize the water. Then it produces oxygen and the proton will accept the electron in the counter electrode. It produces that the hydrogen. So the stability also we have checked. It shows that the excellent stability, the material stability also is good. So in our lab we have developed several systems. So we adopted two strategies, powder based one, thin film based one. Then we found that the thin film based one is a efficient way. Further we want to scale up because what are the results you have seen here, that is the TRL3. So I just want to go beyond that. So for that we have scaled up the electrode from 1 centimeter square to say 25 centimeter square. Then we developed this prototype photoelectrochemical cell. Then we have tested the performance. You just look at this, when we increase the area, the photocurrent got increased. But we want to check whether the 25 centimeter square is behave like a 1 centimeter square. For that, we have converted into this current density, then the trend will be reversed. So you just, then we just want to suppress these things. Then I got idea from this picture. Then I have modified my electrode deposition method like this. Then we have checked that the loss, efficiency loss. So when we go for a 25 centimeter square, almost 50% efficiency is reduced. So then we have modified the electrode rather than the plain electrode. We have a line pattern and a grid pattern. So finally we have reduced the efficiency loss, in this case 27%. Further we have added the sacrificial agent. We have reduced it to 20%. Then we have checked that the hydrogen production rate by applying the different potential. So we are able to get 227 micromole per hour per centimeter square. This is the summary of my presentation. So initially we have talked about the importance of the hydrogen and the type of photoelectrochemical cell which is used for the hydrogen production. Then the materials which can be used for the hydrogen production. Finally, I have showed that how we have developed the this prototype photoelectrochemical cell. So this is the related publication which is start from the lab scale and end up with the prototype. So this is the recognition we have received from that Department of Science and Technology. So one of my students for her pioneer contribution in the green hydrogen production, she was awarded and selected for the Lindau 74th Lindau Nobel Art meeting at Germany last June to July. So this is the one recognition for this green hydrogen production. Finally, this is the acknowledgement, and I would like to thank my all teammates. Thank you. So this is the take-home message for all the young students. Thank you for your kind attention.
Thank you, sir.
If you have any queries.
Sir, thank you very much for your lecture on this solar energy is converted into the hydrogen energy. So I request if the audience have any questions, please. Any clarification, any questions from audience? Okay. Sir, now recently there is that fuel from water, they are converted into the gas and it is burning.
Sir, water from the fuel that will be produced through electrolysis method. So after the electrolysis process, the hydrogen will be used in that particular stove, I think. Yes. So there also, if you go with that kind of things, so there also you need electricity for producing the hydrogen.
Okay. So now which type of fuel is efficient for producing the hydrogen? You are now trying with solar.
Sir, actually I already pointed out the hydrogen having different color codes like grey hydrogen, pink hydrogen, blue hydrogen. So if you go with any grey hydrogen or blue hydrogen, whatever it may be, it will pollute the environment. So if you go with the green hydrogen, so especially the anion exchange membrane based electrolyzer, proton exchange membrane based electrolyzer, this is the promising solution for making the green hydrogen.
Okay. Thank you, sir. Thank you very much.
Thank you.
For wonderful lecture on this.
Wonderful. Wonderful presentation, sir. I cordially invite Professor Dr. B. Jaikar, Director Clinical Trials from VMRF to honor Dr. A. Pandikumar, sir.
Sir.
Thank you, sir. I also invite Dr. A. Pandikumar, sir, to honor the chairperson of the session. Thank you, sir. Next, Dr. D. Kalpana, Senior Scientist. She is going to deliver a keynote session. I would like to invite the chairperson, Professor Dr. P. Nanasekar, Director, IIE from VMRF DU, Salem. So over to you, sir.
Good afternoon, all. It's a pleasure to be before you for this keynote speech during this iNEEBA conference. It's really surprising to see this number of delegates sitting after a heavy lunch. and topics like this are really tough to sit, right? But I do hope this session will tingle your senses and keep you awake. Like what people say, anything small can do wonders. So that is how nanotechnology can do wonders, and it's doing wonders in the scientific community. So today's session, which is on nanotechnology for a sustainable future, when we look at the sustainable goals, out of the 17 goals, nanotechnology can play a role in all the 17. So that technology. And today's speaker, she is going to elaborate on a multifaceted pathway towards energy, environment and health. She has taken 3 goals of the SDGs and how nanotechnology can impact the energy scenario, the environment scenario and the health scenario. And today's speaker, Dr. Kalpana, she is Senior Principal Scientist at SECRI, Chennai. She completed a PhD in Physics Electrochemistry in the year 2004 from the University of Madras. She is a postdoctoral fellow from Cheonan National University, South Korea. Her research interests include hydrogen storage, portable fuel cells, and supercapacitors. She has guided more than 35 PhD scholars, and she is a recipient of Senior Research Fellow from the CSIR Delhi and a Visiting Scientist Fellow for Material Research Center, IISc, Bangalore, and also Fellow of the Academy of Sciences, Chennai. She has more than 80 plus research publications. She has authored a book, chapter, and having a H-index of 26 with over 3,000 citations. Dr. Kalpana carried out projects from BEL, CSIR, DRDO, IMFT, DAE, etc., and reviewed many projects, including projects from the Republic of Kazakhstan. She is also a reviewer of many high-impact journals and also the recipient of awards which include the Young Scientist Award, the Best Paper Award, and the Gold Medal for Best Presentation at various conferences. She has also been awarded the Outstanding Woman of the College from the Government College of Women, Pudukkottai, during her UG. She has evaluated plenty of theses and also delivered lectures across various forums. I'm happy to introduce you today's speaker for this session, Dr. D. Kalpana. The stage is yours, ma'am.
Thank you very much, sir, for the nice introduction. Sir, as you said, it's a great lunch. Taking a lecture, giving a lecture after great lunch is very difficult, but it is except Vinayaka. Because I have seen this college students are very, very sincere, very self-disciplined. I wonder, see, even the hall is almost half filled, isn't it? Isn't it? Am I right? Correct, dane? Ah, very good. Ella clap pannikonga. Because I am appreciating you. Thank you for the wonderful opportunity to meet the young scientist and beautiful campus. I am coming all the way from Chennai. The previous speaker is my junior from headquarters. Have you heard about CSIR? கேள்விப்பட்டிருக்கீங்களா? CSIR, Council of Scientific and Industrial Research. தெரியுமா? How many of you are coming from காரைக்குடி? காரைக்குடி தெரியுமா? எங்களுக்கு செட்டிநாடு சாப்பாடு தான் தெரியும். செட்டிநாடு சாப்பாடோடு சேர்த்து செக்ரின்னு ஒன்று இருக்குது தெரியுமா? சென்ட்ரல் எலக்ட்ரோகெமிக்கல் ரிசர்ச் இன்ஸ்டியூட். இட் இஸ் அவர் பேரண்ட் லேப். சார் வந்து இன்ட்ரடியூஸ் பண்ணாங்கல்ல, அது சும்மா அவருக்கு டைம் பாஸ் இல்லை. இட் இஸ் டு இன்ஸ்பயர் யூ. we have grown up in that way only. யாராவது ஒருத்தவங்க பேசினா அவங்கள பற்றி இப்படிலாம் சொல்கிறாங்களே அப்படின்னு சொல்லிட்டு we also wanted to become like that. ஸோ அந்த மாதிரி இன்ஸ்பிரேஷனுக்காக தான் இந்த இன்ட்ரொடக்ஷன் கொடுக்குறது. நீங்கள் ஏதோ பேசுங்க, நாங்கள் ஏதோ பேசுகிறோம் அப்படின்னா விநாயகா மிஷனில் அது நடக்காதுங்கிறத நான் தெரிஞ்சுக்கிட்டேன். ஓகே ஓகே ஃபைன். So this is my topic. Nanomaterial காலையிலேருந்து பேசியிருப்பாங்க. Just to a layman என்ன சொல்கிறது ஐடியா நானோமெட்டீரியல்ஸ் ஏன் சொல்கிறாங்க தெரியுமா? Have you heard about it? I think all of you can follow தமிழ். தமிழில் பேசினா மட்டும்தான் நீங்கள் கவனிப்பீங்கிறது எனக்கு தெரியும். நான் அங்கே தான் உட்காந்து நான் கவனித்தேன். He was an excellent scientist. He has done wonderful research work. யாராவது கவனிச்சிங்களா? இல்லை. கேட்டால் தாய்மொழியில் பேசினா தான் இதயத்துக்கு போகும் அப்படிங்கிற இதெல்லாம் இருக்குது இல்லையா? I know. Wonderful scientist. He has done lots and lots of work. எவ்வளோ citations. இதெல்லாம் உங்களுக்கு புரியுமா என்னன்னு தெரியல. Many research scholars might be knowing what is impact factorனா என்ன, high impact factor journalsனா என்ன, ஒரு பேப்பர் எழுதுறது எவ்வளோ கஷ்டம், how much effort you have to put, how much time it will take, how much creativity, because you are living in a competitive world. நீங்கள் இப்போ யோசிச்சுட்டு இருக்கும்போது 4 பேப்பர் 5 பேப்பர் லட்சம் பேப்பர் வந்திருக்கும். நீங்கள் 7 ஆரம்பிப்பீங்க, இசட்டில் போய் முடிஞ்சிருக்கும். ஸோ யூ ஹாவ் எவ்ரி திங் இன் யுவர் ஹேண்ட். நீங்கள் இப்போ பேசக்கூட அது டைப் பண்ணக்கூட வேண்டாம் ஒரு சர்ச்சுக்கு. ஜஸ்ட் யூ ஹாவ் டு ஸ்பீக் இட். உடனே உங்களுக்கு ஆன்சர் வந்துடுது. எல்லாருமே யோசிச்சாங்கன்னா எல்லாருமே இருக்குது. ஸோ ஐ ஃபீல் we are not in that era. இப்போ நீங்கள் இருக்கிறது highly competitive world because sources, lots and lots of sources available. உங்கள் கைவசம் எல்லாமே இருக்குது. we used to go to IIT for taking a Xerox. பட் அதில் வந்து ஒரு அந்த ஸ்மெல்லு பெட்ரோல் ஸ்மெல்லு வந்து அவ்வளோ நல்லாயிருக்கும். இந்த பேப்பர் புதுசு. I don't know what are the things precious to you. எங்களுக்கு ஒவ்வொரு விஷயமும் வந்து ப்ரெஷியஸாக இருக்கும். even a letter is very precious to us. Giving respect to the teachers is precious to us. ஒரு டீச்சர் வந்தாங்க அப்படின்னா எந்திரிச்சு நிற்கணும் அப்படிங்கிறது வந்து கவனிக்கணும் அப்படிங்கிறதெல்லாம் வந்து இட்ஸ் அ ப்ரிஷியஸ் திங் ஃபார் அஸ். பட் இருக்குன்னு நினைக்கிறேன், இந்த மிஷனில் இருக்குன்னு நினைக்கிறேன். ஐ ஹோப் இட் வில் ஆல்சோ கண்டினியூ. ஸோ CSIR இட் இஸ் அ சென்ட்ரல் கவர்மெண்ட் ஆர்கனைசேஷன். ஸோ அங்கே வந்து பார்த்திங்கன்னா we have all over India 37 laboratories starting from NAL இருந்து even you name any discipline, I will tell you the lab. 37 laboratories. உங்களுக்கு you have a bright future in CSIR. any field, எந்த ஃபீல்டாக இருக்கட்டும். பிகாஸ் இப்போ இருக்கிறது வந்து பார்த்திங்கன்னா hybrid, interdisciplinary, that matters a lot. I am a physicist. I did my MPhil, MSc, எல்லாமே ஃபிசிக்ஸில் தான் பண்ணேன். பட் ஐ டுக் மை MPhil ப்ராஜெக்ட் இன் பேட்ரி. ஸோ மை டாபிக் ஹாஸ் கம்ப்ளீட்லி சேஞ்ச். என்னோட PhD வந்து கம்ப்ளீட்டாக சேஞ்ச் ஆகிடுச்சு. ஐ எம் த ஃபர்ஸ்ட் பர்சன் டு ரிசீவ் அ இன்டர்டிசிப்ளினரி அவார்ட் ஃப்ரம் யூனிவர்சிட்டி ஆஃப் மெட்ராஸ். ஓகே, நான் வந்து என்னோடய சயின்ஸ் ரிசர்ச் பற்றி பேசுகிறதுக்கோ நான் வந்து இப்படியெல்லாம் பண்ணியிருக்கேன்னு சொல்கிறதுக்கோ இல்லை. ஐ ஜஸ்ட் வாண்டட் டு த்ரோ வாட் ஆர் த திங்ஸ் அவைலபிள் ஃபார் யூ இன் ஃபியூச்சர், வாட் ஆர் த சேலஞ்சஸ் அவைலபிள் ஃபார் யூ இன் ஃபியூச்சர். நானோ மெட்டீரியல்ஸ்ன்றாங்க. எதுக்கு நானோ மெட்டீரியல்ஸ்? சிம்பிளாக சொல்லட்டுமா? நீங்கள் பொண்ணுங்க, அழகான பொண்ணுங்க இருக்காங்க, ஹேண்ட்ஸம் பாய்ஸ் இருக்காங்க. எத்தனை பேர் வீட்டில் வந்து கபோர்டை வந்து நீட்டாக வச்சுருப்போம், இல்லை புக் ஷெல்ஃபை நீட்டாக வச்சுருப்போம்? புக் ஷெல்ஃபை நீட்டாக வச்சுருப்பீங்களா? வச்சுருந்தீங்கன்னா யூ ஆர் த பெஸ்ட். சப்போஸ் என்ன பண்ணுறீங்க, வார்டன் வராங்க, டீச்சர் வராங்க அப்படின்னு சொன்னால் யூ வில் டம்ப் த மெட்டீரியல், ஒரு கபோர்டுக்குள்ளே அடைச்சிருவீங்க. ஜஸ்ட் இது ப்ரெஸ் பண்ணாமல், எதையுமே வந்து ஃபோல்டு பண்ணாமல் அன்ஃபோல்டு அப்படியே அடைச்சிருவீங்க. ஃபுல்லாக கமந்து உள்ளர இருக்கும். ஒன்ஸ் யூ ஓப்பன் இட் தபன்னு விழுகும். பட் யூ டேக் யூர் டைம் எடுத்து அழகாக எல்லாத்தையும் மடித்து ஒரு ஆர்டராக வச்சிங்கன்னா நாட் ஈவன் 2 racks வில் பி ஃபில்டு. 4 racks வந்து என்னவாக இருக்கும், காலியாக இருக்கும். உங்களோட மெட்டீரியல் சேம் ட்ரெஸ், everything is same, the size, everything is same, space was also same, but when you are keeping this in orderly manner, you are getting more space. That is what nanomaterial. nanomaterial அதான் ஒரு பெரிய விஷயத்தை மேக்ரோ சைஸில் இருக்கிறத அதோட ப்ராப்பர்ட்டியோ அதோட கேரக்டரிஸ்டிக்ஸோ எதுவுமே டிஸ்டர்ப் ஆகாமல் சின்னதாக கொண்டு வரும்போது யூ வில் கெட் மோர் ஸ்பேஸ் ஃபார் எனர்ஜி சோர்சஸ். அதுதான் நானோ மெட்டீரியல். நானோ மெட்டீரியல் பெரிய விஷயம் ஒன்றும் கிடையாது. திஸ் இஸ் வாட் ஃபேமன் சொன்னது, தெர் ஆர் மெனி ரூம்ஸ் அண்டர் த சி அப்படின்ட்டு. ஓகே, ஸோ நானோ மெட்டீரியல்ஸ் புரிஞ்சுதா வாட் இஸ் நானோ மெட்டீரியல்னு? திஸ் இஸ் வாட் வித்தவுட் சேஞ்சிங் த ப்ராப்பர்ட்டிஸ் யூ ஆர் மேக்கிங் எவ்ரி திங் இன் டு எ ஸ்மால் சைஸ். அதுதான் வந்து நானோ. ஓகே, ஸோ இப்போது செக்ரிங்கிறது வந்து காரைக்குடியில் இருக்குது. இட் இஸ் அவர் ஹெட் குவார்ட்டர்ஸ். வி ஹாவ் அ யூனிட் இன் சென்னையில் இருக்குது. அண்ட் 2 things ஆர் வெரி எக்ஸ்க்ளூசிவ். ஒன் இஸ் த ஃபியூயல் செல். பேசினார் இல்லையா, ஃபியூயல் செல்ஸில் ஐ எம் ஒர்க்கிங் ஆன் ஃபியூயல் செல்ஸ். இன்னொன்று வந்து பார்த்தீங்கன்னா எக்ஸ்க்ளூசிவ்லி ஃபார் லித்தியம் அயான் பேட்டரிஸ். இந்த 2 விஷயம் தான் ஒர்க் பண்ணுறோம். உங்களுக்கு நிறைய சேலஞ்சஸ் இருக்குதுன்னு சொன்னேன். ஃபார் ஈஸி திங், உங்கள் முன்னாடி இருக்கிறது எல்லாமே இந்த நானோ டெக்னாலஜிலேருந்து எனர்ஜி இஸ் வெரி மச் நீடட், என்விரான்மெண்ட் இஸ் ஆல்சோ ஷுட் பி ப்ரொடெக்டட் பை நானோ மெட்டீரியல் அண்ட் ஹெல்த் இஸ் ஆல்சோ தேர். இங்கே இப்போ எல்லாமே இருக்குது. பட் ஹவு ஃபார் யூ ஹாவ் நோன் அபவுட் இட், ஹவு ஃபார் யூ ஆர் கோயிங் டு எக்ஸ்ப்ளோர் இட் அப்படிங்கிறத பற்றி தான் நான் வந்து ஒரு சில விஷயங்கள் சொல்ல போகிறேன். ஓகேயா? ஓகே, பிஃபோர் தட் ஐ வாண்டட் டு ப்ளே அ வீடியோ. பார்க்கலாமா? எஸ். கவனிச்சிங்கன்னா தான் வீடியோ போடுவேன், இல்லைன்னா போட மாட்டேன். சார் எக்ஸ்கியூஸ், உங்களுக்கு தெரியுமா? She is our Director General of CSIR. இந்தியாவில் இருக்கிற 37 லெபார்ட்டரிக்கும் இவங்க தான் டைரக்டர் ஜெனரல், டாக்டர் என் கலைசெல்வி. எதுக்கு இவங்களை பற்றி சொல்ல வரேன்னா, நான் வந்து இன்ட்ரொடக்ஷனில் அதை எழுதுவேன். பிகாஸ் ஐ எம் கம்மிங் ஃப்ரம் புதுக்கோட்டை. எங்கே போனாலும் நான் அதை சொல்லுவேன். ஐ எம் கம்மிங் ஃப்ரம் அ பிளேஸ் கால்டு புதுக்கோட்டை. நான் கவர்மெண்ட் காலேஜில் தான் படித்தேன். +1 +2 கவர்மெண்ட் ஸ்கூலில் தான் படித்தேன். இப்போ இருக்க பேரண்ட்டுக்கோ இப்போ இருக்க ஸ்டூடெண்ட்டுக்கோ சிபிஎஸ்சியில் படித்தாதான் பெரிய பிள்ளையாவாங்க, சிபிஎஸ்சியில் படித்தாதான் இருப்பாங்கங்கிறதெல்லாம் நாங்களாம் உடச்சிட்டு வந்தவங்க. அந்த மாதிரி தான் எங்களோட டைரக்டர் மேடமும். ஷீ ஆல்வேஸ் யூஸ் டு சே ப்ரவுட்லி தட் ஷீ இஸ் ஆல்சோ கம்மிங் ஃப்ரம் அ வெரி புவர் வில்லேஜ். திருநெல்வேலி பக்கத்தில் ஒரு கிராமத்துலேருந்து வந்திருக்காங்க. ஷி ஹஸ் ஆல்சோ ஸ்டடிட் ஃப்ரம் கவர்மெண்ட் காலேஜ் அண்ட் கவர்மெண்ட் ஸ்கூல்ஸ். நவ் ஷீ இஸ் பிகம் ஹெட் ஆஃப் 5,000 மோர் தென் 5,000 சயின்டிஸ்ட். அதுக்கப்புறம் இவர் டாக்டர் ரமேஷா. மைனா படம் பார்த்துருக்கீங்களா? எவ்வளோ ஒரு ரிமோட் இது பிளேஸ், அது மாதிரியான எலக்ட்ரிசிட்டியே இல்லாத ஒரு இடத்துலேருந்து வந்தவர் தான் டாக்டர் ரமேஷா, அவர் டைரக்டர். அவர் பார்த்திங்கன்னா அவங்க வீட்டில் மின் வேலி அமைச்சிருக்காங்க ஃபுல்லாக அவ்வளோ ஒரு ஹில் ஏரியாவில். பட் ஹீ ஹஸ் ஸ்டடிட் ஃப்ரம் IISc. நவ் ஹீ இஸ் பிகம் த டைரக்டர். எதுக்குமே எனக்கு இதனால் முடியாது, ஐ எம் கம்மிங் ஃப்ரம் திஸ் பிளேஸ் அண்ட் தட் பிளேஸ், அதனால் ஐ கேனாட் அச்சீவ் திஸ் அப்படிங்கிறதால் நீங்கள் எக்ஸ்கியூஸ் சொல்லக்கூடாது. அப்படிங்கிறதுக்காக தான் ஐ எம் புட்டிங் திஸ் PPT. ஓகே, அதில் இது போடுங்க வீடியோ. வெளில வாங்க. So this is about Chennai unit. What we are doing here in Chennai unit, as I told you, we are working on fuel cells and lithium-ion batteries. We have state-of-the-art all the facilities for lithium-ion batteries and fuel cells also. Starting from or stack chinna assembly layer, small cell layer, stack varaikum, we have the facility. Please play this.
Madras unit, based in Chennai, is a satellite unit of pioneering CSIR, Central Electrochemical Research Institute of Karaikudi. Since 10 years, this unit is dedicated towards the development of energy generation and storage related product development, and also caters to the needs of many industry-driven research programs on fuel cells, sponsored by various agencies including government bodies and private sectors. Many membrane electrode assemblies, MEA, of different area and its process parameters are optimized at Sikri Madras unit through different forms of decal, spray and brush coating. The best optimized version of MEA for its testing at the single cell level is done initially to benchmark the performance criteria. Sikri Madras unit has sophisticated electrochemical characterization facilities for basic research to understand the catalytic activity of the electrocatalysts, ionic conductivity of the membranes, and fuel cell test station. Generating energy through fuel cells is an important aspect wherein Sikri joins hands with companies such as Messiers Reliance, KPIT and Thermax in developing various types of water-cooled and air-cooled fuel cell stacks. The stacks implemented in Patalganga are an evidence for our expertise in this field. What you see here is Sikri's indigenously made portable fuel cell power center combines low-cost fuel cell and solid hydrogen cartridge. Once hydrogen is connected, the fuel cell starts producing electricity and the power is made available through a standard USB socket. It gives a net power output up to 10 watts. Every month, 10 million lithium-ion cells are being imported to India in a step towards self-reliance to meet our requirements. Sikri, under our PM's Make in India program, has installed India's first pilot prototype lithium-ion fabrication facility with initial capacity of 100 cells per day that has applications in defense, solar-powered devices, railways and other high-end usages. CSIR SICRI is spearheading the project in lithium-ion battery technology under TAP Sun and products with Sun Utilization Network Store Solar Program. Through this project, SICRI has successfully installed lithium-ion cell configuration, namely 18650. CSIR SICRI has indigenously developed 3.7 volt 1500 mAh lithium-ion cells using proprietary materials, which has been successfully used for powering solar lanterns and hats. Now the facility is open to all. So, big players involved in LIB marketing, medium-grade manufacturers and small-scale researchers can make use of this facility and demonstrate our capability in this indigenous lithium battery technology. SICRI, Madras Unit, Lithium-Ion Battery R&D, extremely focuses on synthesizing of novel materials such as metal oxides, oxyfluorides, fluorophosphates, fluorosulfates, Nasicon type materials. SICRI, Madras Unit, has very good quality and quantity of publications covering a diverse spectrum of materials related to lithium, sodium batteries. A large number of scholars have completed PhD in these areas, and an equal number is pursuing PhD on advanced materials for futuristic systems such as lithium batteries, sodium-ion batteries, green organic batteries, lithium sulfur and lithium air batteries. The research work on materials for energy applications focuses on mixed metal oxide compounds belonging to pyrochlore, fluoride, perovskite structured family of compounds. The strength of this unit is directed towards the development of new processes, technologies, products, and novel use of electrochemistry. SICRI, Madras Unit, based in Chennai, is a satellite unit of pioneering CSIR.
So you know about energy sources. One is renewable energy and another one is non-renewable energy sources. In the renewable sources, we have one more thing. It is called alternate energy sources. So in the alternate energy sources, we have 4 types. So I think that
different with that.
So in another 50 years, the top 10 problems humanity means human going to face is the energy. This one. See, ready next poll. So we have energy battery, fuel cells and supercapacitors. In that batteries we say energy storage device because energy is stored in the form of chemical and the chemical energy is converted into electrical energy. And fuel cells we say energy conversion device because we have as like batteries we have an anode and cathode. Anode la vandu hydrogen will be fed, cathode la oxygen will be fed. So இது ரெண்டும் சேர்ந்து electrons வந்து produce பண்ணி H+. As soon as the hydrogen touches the catalyst, H+ ஆகும் 2 electron வந்து outside the circuit வரும். So அந்த electron will conduct current. உள்ள வந்து H+ வந்து oxygenோட சேர்ந்து H2O வந்து water வந்து byproduct கொடுக்குது. That is what we say hydrogen is a clean and green energy source அப்படினு சொல்றது. In next years hydrogen and hydrogen based fuel cells will be the source of energy. இப்போ கூட நீங்க பார்த்திருப்பீங்க most of the vehicles e-vehicles வந்து they are running out of petrol, electric vehicles with battery and hybrid கேள்விப்பட்டிருக்கீங்களா both batteries as well as any kind of fuel cells இதெல்லாம் தான் ஓடிட்டு இருக்கும். Okay, batteriesல வந்து பாத்தீங்கன்னா there are 2 kind of batteries you might have studied in your +2 or you might have heard about it. One is primary battery, another one is secondary batteries. Primary batteries are non-rechargeable batteries. It is use and throw batteries, where in the madri electronic chinna watches, okay, watches la chinna AC remote la indha mari use பண்றது எல்லாமே use and throw batteries, whereas secondary batteries ingradhu rechargeable batteries. Particularly the rechargeable batteries la lead acid batteries இருக்கு. Any kind of four wheeler applications lead acid battery வந்து இதுவரைக்கும் replace பண்ணவே முடியல. Though it has many problems. Lead வந்து being a heavy metal சொல்லுவாங்க. அதுல வந்து H2SO4 liquid electrolyte because short circuit வரும் அப்படின்றாங்க. But the energy density, the high energy density can be achieved only with sulfuric acid, where lead acid battery is having the major key role in vehicular applications. இதுக்கு அடுத்து வந்து பாத்தீங்கன்னா lithium batteries. 1800ல வந்து history of batteries ஆரம்பிச்சாலுமே 1990ல Sony battery தான் வந்து first time they are using batteries for electronic equipments. அப்பதான் வந்து battery field has gotten limelight 1990sல. So 1990sலேருந்து the progress of being batteries coming out of commercialization has started. Okay, so அந்த பேட்டரிஸில் வந்து பார்த்தீங்கன்னா லித்தியம் பேட்டரிஸுக்கும் லித்தியம் அயான் பேட்டரிஸுக்கும் சில டிஃப்ரென்ஸ் இருக்குது. லித்தியம் வந்து வெரி எக்ஸ்ப்ளோசிவ். ஸோ அந்த லித்தியம் வந்து ஹைலி காஸ்ட் எஃபெக்டிவ், இட் இஸ் நாட் காஸ்ட் எஃபெக்டிவ் ஆல்சோ. ஸோ அதை கட் டவுன் பண்ணுறதுக்காக மெட்டல் ஆக்சைட்ஸை வந்து இன்ட்ரடியூஸ் பண்ணி லித்தியம் மெட்டல் ஆக்சைட்ஸ் அதை வந்து கேத்தோடாகவும் எனி கைண்ட் ஆஃப் லித்தியம் மெட்டலையோ இல்லைனா கார்பனையோ ஆனோடாவும் சேர்த்து கொண்டு வந்தாங்க. இதுக்கு பேர் வந்து ராக்கிங் சேர் பேட்டரிஸ்ன்னு சொல்லுவாங்க. ஏன்னா சார்ஜிங் அப்போ ஒரு லித்தியம் வந்து இங்கேருந்து மூவ் ஆகி ஆனோட்லேருந்து கேத்தோட்லேருந்து ஆனோடுக்கு போகும். அங்கேருந்து திருப்பி ரீசார்ஜ் அப்போ ஆனோட்லேருந்து கிளம்பி கேத்தோடில் வரும். ஸோ இந்த மாதிரி போயிட்டு வர்றதுனால தான் இட் இஸ் கால்ட் லித்தியம் ராக்கிங் சேர் பேட்டரிஸ்ன்னு பேர். ஓகே, இந்த லித்தியம் அயோடின் பேட்டரின்னு ஒன்று இருக்குது. நான் வந்து ஐ வாண்டட் டு கவர் ஹவு நானோ மெட்டீரியல்ஸ் ஆர் யூஸ்டு ஃபார் மெடிக்கல் அப்ளிகேஷன்ஸ் ஆல்சோ. இது இருக்கா ஒன்லி பிபிடி? சரி, ஓகே. ஸோ இதில் மெடிக்கல் அப்ளிகேஷன்ஸில் வந்து பார்த்தீங்கன்னா ஒன்று வந்து மெயினாக வந்து ஃபார் வாட் இஸ் இட் ஸ்பைனல் கார்டு இன்ஜுரி மெடிக்கல் லித்தியம் அயோடைன் பேட்டரிஸ்ன்னு இருக்குது. இப்போ ஃபார் எக்ஸாம்பிள் ஒரு பேஸ் மேக்கர் வைக்கிறாங்கன்னு பார்த்துருக்கீங்களா? பேஸ் மேக்கர் வந்து யூகேயில் வந்து லண்டன்லலாம் பார்த்தீங்கன்னா 1 in 10 people are having the disease called, it is not a disease, it is a symptom called murmur அப்படிம்பாங்க. Normally for 1 minute our heartbeat will be pumped for 70 to 80 minutes. ஸோ இதை விட லோவாக இருந்தாலோ இதை விட ரொம்ப ஹையாக இருந்தாலோ அதுக்கு பேர் வந்து ஒரு சிம்டம் இருக்குது. அந்த சிம்டம்காக டாக்டர்ஸ் வில் பி கீப்பிங் பேஸ் மேக்கர். பேஸ் மேக்கரோட விஷயம் என்னன்னு கேட்டிங்கன்னா இட் ஹேஸ் டூ மெயின் திங்ஸ். ஒன் இஸ் ஃபர்ஸ்ட் இட் ஹேஸ் டு சென்ஸ் இட். ஹார்ட் பீட் வந்து நார்மலாக இருக்கா, லோவாக இருக்கா, ஹையாக இருக்காங்கிறத வந்து ஃபஸ்ட்டு சென்ஸ் பண்ணோம். அதுக்கப்புறம் இட் வில் இன்டியூஸ் எலக்ட்ரிக்கல் ஸ்டிமுலேட் பண்ணிவிட்டு ஹார்ட்டை ஸ்டிமுலேட் பண்ணிவிட்டு அந்த ரிதமை வந்து நார்மல் ஆக்கும். ஸோ அந்த பேஸ் மேக்கருக்கு என்ன யூஸ் பண்ணுறாங்க? பேட்ரி தான் மெயின் இம்பார்ட்டன்ட். நானோ பேஸ்டு மெட்டீரியல் பேட்டரிஸ் தான் வெரி வெரி இம்பார்ட்டன்ட். பிகாஸ் பேஸ் மேக்கருங்கிறது வந்து ஒரு ஃபாரின் மெட்டீரியல். யோசிச்சு பாருங்கள், நம்ம சாப்பிடும்போது ஒரு பருக்க உள்ளே போனாலே என்ன பண்ணும்? நமக்கு ஹிக்கப்ஸ் வரும், புறையேறி அந்த சாப்பாடை வந்து வெளியில் அனுப்பிடும். வென் யூ ஆர் when you are implanting a battery in your body, அப்போ வந்து எவ்வளோ சேஃபாக இருக்கணும். இட் ஷுட் நாட் ஹேவ் அ கேலண்டர் ஃபேடுன்னு பார்த்தீங்கன்னா, ஃபார் எக்ஸாம்பிள் உங்கள் ஃபோனில் நீங்கள் ஃபோன் யூஸ் பண்ணியிருக்கீங்க இல்லையா? ஃபோன் வந்து நீங்கள் 100% சார்ஜ் பண்ணியிருப்பீங்க. ஈவன் இஃப் யூ ஆர் நாட் யூஸிங் அது என்ன ஆகும்? கொஞ்சம் கொஞ்சமாக குறைஞ்சிட்டு வரும். 100லேருந்து 80 வந்திருக்கும், சம்டைம்ஸ் 90 வந்திருக்கும். டிபெண்ட்ஸ் அப்பான் த பேட்டரி யூ ஆர் யூஸிங். அப்போ என்ன, அதுக்கு பேர் வந்து செல்ஃப் டிஸ்சார்ஜ்னு பேர். ஈவன் இஃப் யூ ஆர் நாட் யூஸிங் the ions will automatically start moving. ஸோ அதுக்கு பேர் தான் செல்ஃப் டிஸ்சார்ஜ். ஒரு பேஸ் மேக்கரில் இம்ப்ளான்ட் பண்ணும்போது அதுக்கு வந்து செல்ஃப் கேலண்டர் ஃபேடு வந்து இருக்கக்கூடாது. அதே மாதிரி இட் ஷுட் பி ஆஸ் சேஃப்டி ஆஸ் பாசிபிள். பிகாஸ் ஒரு ஃபாரின் பார்ட்டிகிள் வந்து நம்ம பாடியில் வந்து கொண்டு வர்றோம். ஸோ திஸ் இஸ் வாட் ஐ டோல்ட் யூ, திஸ் ராக்கிங் சேர் பேட்டரி. இது வந்து திஸ் இஸ் பிரைமரி பேட்டரி, நான் ரீசார்ஜபிள் பேட்டரி. திஸ் இஸ் கால்டு சார்ஜபிள் செகண்டரி பேட்டரி. செகண்டரி பேட்டரிஸில் வந்து we have many kinds. So first is the lead acid battery and zinc, nickel, cadmium, nickel metal hydride, lithium ion. So the interesting thing about this nickel cadmium battery is the memory effect. மெமரி எஃபெக்ட்னா ரொம்ப ரொம்ப இன்ட்ரெஸ்டிங்கானது. as soon as நீங்கள் ஒரு ஃபோன் வாங்கும்போது கடைக்காரர் தெளிவாக உங்கள்கிட்ட சொல்லுவார் 8 hours வந்து சார்ஜ் பண்ணிட்டு தான் நீங்கள் யூஸ் பண்ணணும் அப்படிம்பார். நம்ம என்ன பண்ணுவோம்? ஃபோனை வாங்குவோம், பிரிப்போம், உடனே செல்ஃபி எடுப்போம், ஃபோட்டோ எடுத்து வாட்ஸ்அப்பு, ஃபேஸ்புக்கு எல்லாத்துலேயும் ஷேர் பண்ணுவோம். அது பாட்டுக்கு ஏறினா ஏறலைன்னா போதும். நீங்கள் இது பண்ணக்கூடாது. பிகாஸ் நிக்கல் கேட்மியம் உங்களோட ஃபோனில் பார்த்தீங்கன்னா என்ன டைப் ஆஃப் நீங்கள் பேட்டரி யூஸ் பண்ணுறீங்கிறது போட்டிருக்கும். வெதர் இட் இஸ் லித்தியம் அயான் பேட்டரி ஆர் லித்தியம் மெட்டல் ஹைட்ரேட் பேட்டரி ஆர் நிக்கல் மெட்டல் ஹைட்ரேட் பேட்டரி அப்படிங்கிறத நீங்கள் போய் பார்க்கலாம். இப்போ வந்து earlier it was starting by 1500 milliampere per gram per ampere hour. இப்போ வந்து என்னாச்சு 7000 எல்லாம் கொண்டு போயாச்சு. என் பேட்டரி என்றைக்குமே வந்து டை ஆகக்கூடாது, அப்படியே சார்ஜிங்லேயே இருந்துகிட்டே இருக்கணும், நான் எவ்வளோ ஃபோட்டோ வேணாலும் எடுப்பேன், எவ்வளோ ஸ்டோரேஜ் வேணாலும் இருப்பேன். நாங்கள்லாம் ஸ்டோர் பண்ணது மனசில். we used to share things. நீங்கள் யோசிச்சு பாருங்களேன், உங்களுக்கு ஒரு கொஷின் வந்து டஃப்பாக இருக்குது, WKB அப்ராக்சிமேஷன் ஒரு ஃபிசிக்ஸில் ஒன்று உண்டு. ஐயோ அது அப்படி ஒரு கொடுமை, 4 பக்கம் 6 பக்கம் எதுக்குன்னே தெரியாது, பட் அவ்வளோ ஒரு ஈக்குவேஷன் வரும். பட் அதை பார்த்தாலே ஜுரம் வரும். நீங்கள் யோசிச்சு பாருங்களேன், ஒரு விஷயத்தை இஃப் யூ ஆர் நாட் அண்டர்ஸ்டாண்டிங் யூ ஸ்டார்ட் ஷேரிங் வித் அதர் ஒன். 2 பேர் நீங்கள் சொல்லும் போது ஆட்டோமேட்டிக்காக யூ வில் கெட் டு நோ திங்ஸ். நீங்கள் ஒரு விஷயம் உங்களுக்கு புரியலைன்னா வா சேர்ந்து நம்ம 2 பேர் படிப்போம் அப்படின்னு சொல்லி யோசிச்சு பாருங்களேன், அந்த விஷயத்தை ஈஸியாக நீங்கள் படிச்சிருவீங்க. ஓகே, ஸோ அதே மாதிரி லித்தியம் மெட்டல் ஹைட்ரேட் வந்து பார்த்தீங்கன்னா இட் ஹேஸ் அ மெமரி எஃபெக்ட். மெமரி எஃபெக்ட்னா என்னென்னா, இப்போ சப்போஸ் ஒரு 100 செல் வந்து, ஒரு எக்ஸாம்பிள் நான் சொல்கிறேன், இப்போ 100 செல் வந்து ஒரு கேத்தோட்லேருந்து ஆனோடுக்கு போகுதுன்னா இது வந்து சார்ஜிங். டிஸ்சார்ஜிங் அப்போ என்ன பண்ணணும், ஆல் த 100 எலக்ட்ரான் ஷுட் கம் ஃபார்வர்ட், இந்த பக்கம் வரணும். ஓகே, சப்போஸ் இது வரல, திருப்பி நீங்கள் வந்து சார்ஜ் பண்ணுறீங்க, சார்ஜ் பண்ணும்போது யூ ஆர் சார்ஜிங் அப் டு 80%. ஓகே, திருப்பி நீங்கள் 100% பண்ணும்போது இட் வில் நாட் டூ தட். அது லாஸ்ட்டாக எப்போ நீங்கள் சார்ஜ் பண்ணீங்களோ அந்த ஸ்டேஜில் தான் நின்றுடும். அதுக்காகத்தான் தெளிவாக சொல்கிறது, ஒரு ஃபோன் வாங்கின உடனே யூ ஹேவ் டு சார்ஜ் இட் டு த ஃபுல்லஸ்ட் கெப்பாசிட்டி. கொஞ்சம் பொறுமையாக இருந்து ஃபுல்லஸ்ட் கெப்பாசிட்டி வந்ததுக்கப்புறம் நீங்கள் யூஸ் பண்ண ஆரம்பிக்கலாம். அதை விட்டுட்டு சயின்டிஸ்ட் எல்லாம் என்ன தயாரிக்கிறாங்க, பேட்ரி இங்கே ஏறிது அங்கே ஏறுது, இட் இஸ் ஆல் மேன்மேட் மிஸ்டேக். அப்போல்லாம் வந்து பார்த்தீங்கன்னா இப்போ ஹைட்ரஜன் வந்துருச்சு, ஹைட்ரஜன் ஃபியூயல் ஹேஸ் கம். அப்போது வந்து எல்பிஜி யூஸ் பண்ணுறதுக்கே பயந்தோம் இல்லையா. எல்பிஜியை வந்து வீட்டில் ஒரு சிலிண்டர் கொண்டு வந்து வைக்கும் போதே ஐயோ வெடிச்சிருமோ அப்படி இப்படின்னு பயந்தோம். பட் வி ஸ்டார்டட் யூஸிங் இட் நார்மலி, வெரி நார்மலி. அதே மாதிரி தான் ஆட்டோக்கோ 4 வீலர்ஸுக்கோ யூஸ் பண்ணும்போதும் பயந்தோம், அதே மாதிரி வந்துடுச்சு. ஸோ நெக்ஸ்ட்டு வந்து பார்த்திங்கன்னா இப்போ வந்து எலக்ட்ரிக் வெஹிக்கிள்ஸுக்கு கண்டிப்பாக வந்து ஃபியூயல் செல் வரப்போகுது. ஓகே ஓகே பண்ணி so these are all some of the nomenclatures. ஸோ இதுக்கு முன்னாடி பார்த்தீங்கன்னா ஈவன் ஏர்லி 2000லையாக இருக்கட்டும், ஏர்லி 2020ஸ்லாம் இருக்கட்டும், 2010ஸாக இருக்கட்டும், அப்போல்லாம் பார்த்தீங்கன்னா எலக்ட்ரானிக் எக்யூப்மெண்ட்ஸாக இருக்கட்டும், எனி எலக்ட்ரானிக் கேட்கெட்ஸ் வெதர் இட் இஸ் அ லேப்டாப் ஆர் அ ஃபோன், இது எல்லாமே வந்து எவ்வளோ பெரிய சைஸாக வந்தது இல்லையா. ஹவ் யூ எவர் தாட் எப்படி அந்த சைஸ் குறைஞ்சிது அப்படிங்கிறத சொல்ல முடியுமா? வாட் இஸ் த மெயின் ரீசன் ஃபார் எலக்ட்ரானிக் டிவைஸ் டு பி வெரி கம்ஃபர்டபுள், ஃப்ளெக்ஸி, சின்ன சைஸாக இருக்கிறதுக்கு என்ன காரணம் தெரியுமா? நானோ டெக்னாலஜி. அது என்ன நானோ டெக்னாலஜி வந்தது? நானோ டெக்னாலஜி ஓகே, அது என்ன பண்ணுச்சு நானோ டெக்னாலஜி? அது வெரி குட், கைத்தட்டுங்க அவருக்கு. See, all the electronic devices where battery is used, the battery is deciding the size and the flexibility. யோசிச்சு பாருங்க, உங்களோட செல்ஃபோன் ஃப்ளெக்சிபிள், அந்த இப்போ வந்துருக்குல்லையே சாம்சங்கில் 1 lakhல குக் வித் கோமலையில் கொடுத்தாங்களே ஒரு ஃபோல்டபுள், அதெல்லாம் எதனால? ஒன்லி பிகாஸ் ஆஃப் த பேட்டரி. உங்கள் சைஸ் ஆஃப் யுவர் செல்ஃபோன், சைஸ் ஆஃப் யுவர் ஆல் லேப்டாப் எல்லாத்தையுமே டிசைட் பண்ணுறது ஒரு பேட்டரி தான். ஸோ ஒரு பேட்டரிக்கு வந்து ஷெல்ஃப் லைஃபு, செல்ஃப் டிஸ்சார்ஜ், டெம்பரேச்சர், காஸ்ட்டு, இது எல்லாமே வந்து வெரி வெரி இம்பார்ட்டன்ட். அண்ட் another is temperature range. ஸோ இங்கே சென்னையில் வந்து பார்த்தீங்கன்னா சம்மரில் 40 போகும், டெல்லியில் வந்து 42 45 போகும். பேட்டரி என்ன ஆகும், நார்மலாக நீங்கள் யூஸ் பண்ணும்போதே சூடாகிறோம். ஸோ அந்த டெம்பரேச்சரில் ஈவன் டு த ஹையஸ்ட் டெம்பரேச்சர் த பேட்டரி ஷுட் வித்ஸ்டாண்ட். தயாரிக்கிறீங்க 100 டிகிரி வர வரைக்கும் நீங்கள் பண்ணணும், ரிசர்ச் பண்ணணும் அப்படிங்கிறது இருக்குது. அதே மாதிரி யூ கோ டு காஷ்மீர், ஸ்ரீநகர் போங்க, வெரி கோல்டு டெம்பரேச்சர், ஈவன் சம்டைம்ஸ் இட் வில் கோ பிலோ லோ டிகிரி. ஸோ ஹை டெம்பரேச்சராக இருந்தாலும் சரி, லோ டெம்பரேச்சராக இருந்தாலும் சரி, we have to fabricate a battery to withstand all the kind of temperatures. இன்னொன்று வந்து பார்த்தீங்கன்னா செல்ஃப் டிஸ்சார்ஜ், ஐ ஹவ் ஆல்ரெடி டோல்ட் யூ, மெமரி எஃபெக்ட் ஆல்சோ, அண்ட் ஷாக் ரெசிஸ்டன்ஸ். ஃபோன் வந்துகிட்டே இருக்கும், அம்மா கூப்பிட்றாங்கன்னா என்ன கூப்பிட்டுட்டே இருக்குன்னு போட்டு உடைப்பீங்க, போட்டு உடைச்சாலும் உடையாத ஒரு பேட்டரி தயாரிக்கணும் இல்லையா. ஸோ இந்த மாதிரி பேட்டரி தயாரிக்கிறதுல வந்து we have to think of many characteristics like temperature range, self discharge, memory effect, behavioral resistance, leakage, இது எல்லாத்தையுமே கன்சிடர் பண்ணி தான் பேட்டரி வந்து தயாரிக்கிறாங்க. இதில் வந்து நானோ மெட்டீரியல்ஸ், நானோ டெக்னாலஜிங்கிறது த நானோ மெட்டீரியல்ஸ் யூஸ்டு இன் தட். ஸோ ஸோ அப்போ நானோ மெட்டீரியல்ஸை வந்து பக்காவாக நீங்கள் யூஸ் பண்ணணும். பிகாஸ் நீங்கள் உங்களோட பேட்டரி சைஸ் சின்னதாகும் போது பெரிய மேக்ரோ சைஸ் மெட்டீரியலை வச்சா உங்களோட பேட்டரி வந்து பெருசாக இருக்கும். ஸோ நானோ மெட்டீரியல்ஸை யூஸ் பண்ணும்போது தான் யூ வில் பி கெட்டிங் அ பக்கா ஜியோமெட்ரிக் size. Okay, I have, okay. So this is about the pacemaker. I think I have already told you what are all the two main functions of the pacemaker. So this party is having a pacemaker. இதுக்கு வந்து இப்போ இருக்க ட்ரெண்ட் வந்து பார்த்தீங்கன்னா even remote is outside that. So நீங்கள் வந்து கண்ட்ரோல் பண்ணிக்கலாம். And this is for cochlear application. So how nanotechnology is used in medical applications. So this is one of the spinal cord implantation. சில பேருக்கு chronic back pain இருக்கும். ஸோ அவங்க எல்லாத்துக்குமே வந்து this kind of battery equipped device அது வந்து ஒரு டிங்லிங் எஃபெக்ட் கொடுக்கும். ஒரு மாதிரி இப்படி ஒரு பல்ஸ் கொடுக்கும். அதனால அவங்களோட பெயின் வந்து கொஞ்சம் வந்து ரிலீஸ் ஆகும். அந்த சார்ஜர் வந்து இங்கே இருக்குது பாருங்கள். சார்ஜர் இஸ் ஹியர். திஸ் ஒன்ஸ் இஃப் யூ ஆர் கம் அவுட் ஆஃப் திஸ் பெயின் த சார்ஜர் கேன் பி ரிமூவ்டு. So it is under your skin only. This is for the retinal implantation, those who are having a long sight problem. And this is a very new technology, stretchable battery. So stretchable battery is pathina, suppose if a patient is a coma or bedridden patients, for them the medicine should be given in a proper timing. Yeah. So நீங்கள் வந்து சில பேர் பிஸியாக இருப்பீங்க, அம்மா cannot do or other person cannot do, sometimes nurse will do. So the battery implanted batteries என்ன பண்ணும் அப்படின்னு சொன்னீங்கன்னா you have to set medicines in a particular time, so automatically it will go to the patients. So this is about the stretchable battery. Okay, another one is supercapacitors. I think many of your research scholars might be doing or might have done on supercapacitor. Supercapacitor தான் எனக்கு சொன்னால் இருக்கிறதுலேயே ரொம்ப சிம்பிளான ஒன்று, but you can do wonder in that. The basic difference between a supercapacitor and a battery is battery வந்து பார்த்தீங்கன்னா long time to charge and long time to discharge. Battery, but supercapacitor can be charged and discharged in fraction of second. So long time இருக்கும்போது energy density will be more for a battery. ரொம்ப short durationல charge ஆகிறதுனால power density will be high for the supercapacitor. So இதில் வந்து பார்த்தீங்கன்னா based on the material, supercapacitor has three things. One is EDLC pseudo capacitors and hybrid capacitors. So இதெல்லாம் உங்களுக்கு சொல்ல. Okay. Another one is, okay, I've told you what is the challenge, how the nanotechnology is used in environment. Environmental வந்து பார்த்தீங்கன்னா முன்னாடியெல்லாம் வந்து பார்த்தீங்கன்னா வீட்டுக்கு ஒரு கார் இருக்கும், ஒரு சைக்கிள் இருக்கும். How many of you have the habit of reading newspaper? Newspaper தான் இருக்கும், நிறைய புக்ஸ் தான் இருக்கும். ஓகே, இப்போ வந்து பார்த்தீங்கன்னா ஒரு 25 வயசுன்னா 25 × 3 × 4 அளவு ட்ரெஸ் இருக்கும் இல்லையா? எங்களுக்கெல்லாம் அப்படியெல்லாம் கிடையாது. தீபாவளி, பொங்கல், இந்த மாதிரி பர்த்டேக்கு ட்ரெஸ்ஸஸ் இருக்கும். ஸோ எதுக்கு சொல்ல வரேன்னா அந்த ரீசைக்கிள், ரெடியூஸ், ரீயூஸ் இந்த மூணு வந்து இன்னைக்கு ட்ரெண்டுக்கு வெரி 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 இம்பார்ட்டன்ட். கவர்மெண்ட் இஸ் சீக்கிங் ஃபார் யூ. ஒரு சின்ன ஒரு க்ளூ இருந்தால் போதும், யூ வில் பி கிவன் அன் அவார்ட், யூ வில் பி கிவன் அன் ப்ராஜெக்ட். ஏன்னா இப்போ இருக்க ட்ரெண்டில் 3R, ஹவ் யூ ஆர் கோயிங் டு மேக் திஸ் 3R. இப்போ நாங்கள்லாம் பென்சில், காந்தி பென்சில்பாங்க, இவ்வளோண்டு வர்ற வரைக்கும் தான் பண்ணுவோம். பிகாஸ் அதை வந்து நாங்கள் ரீயூஸ் பண்ணி பார்ப்போம். பட் என் பொண்ணுங்களுக்கெல்லாம் வந்து ரீயூஸுங்கிறதே கிடையாது, ரீப்ளேஸ் தான் சார். உடஞ்சிருச்சா அம்மா வேறு நோட்டு சார், புது நோட்டில் ரஃப் நோட்டுங்கிறாங்க சார். மனசே ஆக மாட்டேங்குது. புது நோட்டை வந்து ரஃப் நோட்டுக்குன்னு காசு கொடுத்து வாங்குறாங்க. எங்களுக்கெல்லாம் வந்து சாணி பேப்பர்னு ஒன்று இருக்கும். அதுக்கப்புறம் அண்ணா படித்த அக்கா படித்த புக்கு இருக்கும். அதில் ஒன் சைட் பேப்பர் இருந்தால் அதை ஒட்டி கிளிப்பு போட்டு, அதெல்லாம் டெக்னாலஜிங்க, அதெல்லாம் ரீயூஸ். நியூஸ் பேப்பர் அழகாக அடுக்கி வச்சு மோல்டு பண்ணுவாங்க தெரியுமா? அதில் தான் கூடை முறமெல்லாம் பண்ணுவாங்க. உங்கள் பாட்டி தாத்தாவை கேட்டு பாருங்கள். ஓகே, எவ்வளோ அழகாக அந்த நியூஸ் பேப்பரை படித்து அந்த ஒரு சைக்கிளை எவ்வளோ அழகாக வந்து யூஸ் பண்ணி எல்லாமே ப்ரெஷியஸாக இருந்தது. அந்த ரெடியூஸ், ரீயூஸ், ரீசைக்கிள்ங்கிற ஃபஸ்ட்டு ரெடியூஸ், தேவையில்லாத வென் யூ டோன்ட் பை எனி திங் வென் யூ டோன்ட் நீட் இட், உங்களுக்கு தேவையில்லாததை வாங்கக்கூடாது அப்படிங்கிறத வந்து கற்றுக்கிட்ட ஜென்ரேஷன் சொல்லலாம். ஓகே, அதை சொன்னால் பேரண்ட்ஸ் சொன்னால், அம்மா அப்பா சொன்னால் நாங்கள் கேட்டுப்போம். நாங்கள் கேட்காமல, நீங்களாம் பார்த்து வளர்றீங்க, நாங்களாம் கேட்டு வளர்கிறோம். நீங்கள் ஃபேஸ்புக் பார்த்து, வாட்ஸ்அப் பார்த்து, ட்விட்டர் பார்த்து, இன்ஸ்டாகிராம் பார்த்து வளர்றீங்க. நாங்கள்லாம் அம்மா அப்பா டீச்சர்ஸ் சொல்கிறத கேட்டு வளர்ந்தவங்க. ஓகே, அதனால நாங்கள் ரொம்ப பெரியவங்கன்னு இல்லை, ஆமாம் பெரியவங்க தான். ஓகே, ரெடியூஸ் பண்ணுறது ஃபஸ்ட்டு. வென் யூ டோன்ட் பை எனி திங் வென் யூ டோன்ட் நீட் இட். நம்ம எத்தனை பேர் அதை செய்கிறோம்? நம்மளால் ஸ்விக்கிக்காரன் இன்றைக்கி முதலாளியாக இருக்கான், நம்மளால் வந்து ஓலாக்காரன், ஊபர், அதெல்லாம் விட கொடுமை சார். சாரி ட்ரேபிஸ்ட், துணிக்கடை சார். நீங்கள் ஒன்று நம்மளை வந்து சோம்பேறி ஆக்குறாங்க. துணி கடைக்கு நீங்கள் போக வேண்டாம், வீட்டுக்கே வரும். அதுவும் சரியில்லைன்னா போட்டு பார்த்துட்டு 10 நாள் கழித்து வாங்கிக்கிறோம். அது யார் போட்டதோ கன்றாவி அது தெரியாது. அதை வந்து வாங்கிக்கிறாங்க. நம்மளை வந்து சோம்பேறி ஆக்குறாங்க. சோம்பேறி தானே என்ன பண்ணோம், வீட்டில் உட்காந்துக்கிட்டே சாப்பிட்றோம். 2 மணி நேரம் நாங்கள் ஹோட்டலில் ஈரோடு அம்மன் மெஸ்ஸில் உட்காந்தாது சாப்பிடவே தவிர அந்த 2 மணி நேரத்தில் வீட்டில் ஒரு தோசை ஊற்றி சட்னி அரைச்சி சாப்பிட மாட்டோம். கரெக்டாக? How many of you are doing? சண்டே ஆனால் வீட்டில் யாருமே சமைக்கிறதே இல்லை சார். இங்கே சேலமில் எப்படின்னு தெரில, சென்னையிலலாம் வந்து சமையல் ஃப்ரீ விட்டுடுறாங்க. சண்டே தான் பார்த்தாலும் எவ்ரி ஈவினிங் எல்லாமே செலிப்ரேஷனாக இருக்குது. பட் எங்கே போகுது இது, எதை நோக்கி போயிட்டு இருக்குங்கன்னு தெரியல. சாரி கட்டுறதுக்கு அவன் சம்பாதிக்கிறான் சார் 20 லட்சம். டாலி ஜெயின்னு ஒரு அம்மா 1 lakh 3 lakhs சம்பாதிக்கிறாங்க ஒரு சாரி கட்டுறதுக்கு. அப்போ யாரோட சோம்பேறித்தனம் வந்து அவங்களுக்கு முதலீடாக இருக்குது. ஸ்விக்கி, சொமேட்டோ, பிஸ்னஸ். ஸோ அவங்களுக்கு பிஸ்னஸ், நமக்கு டிசீஸ். உட்காந்தே இருக்கிறதுனால நோ எக்ஸசைஸ், டயபெட்டிஸ்னால ஹார்ட் டிசீஸ், ஒபிசிட்டினால ஹார்ட் டிசீஸ், அப்புறம் மர்கையா, அவ்வளோதான். ஜிம்முக்கு போய் அங்கே சார் அங்கே இதுவல்ல சார். மிட் நைட் பிரியாணி சென்னையில் விற்கிறாங்க சார். சாதாரணமாக மத்தியானம் எனக்கு சாப்பிட்டதே என்னால் முடியல. 2 மணிக்கு 3 மணிக்கு 4 மணிக்கு அது எப்படி தான் அதை வந்து மிட் நைட் பிரியாணி. அப்போ இன்டைஜஷன், சாப்பிட முடியல. அதுக்கு உடனே சோடா குடி, ஸ்ப்ரைட்டு குடி, அதை குடி, இதை குடி பண்ணுறீங்களா இல்லையா? சேலம் பிள்ளைங்க பண்ணுறது இல்லையா? ஸோ ஸ்வீட் அம்மா, நிஜமாக அதான் நீங்களாம் ஒல்லியாக அழகாக இருக்கீங்க. வெரி குட். டைம் ஆச்சா? நானும் ட்ரெயினை பிடிக்கணும். ஒரே நிமிஷம். நோட்டீஸ் கொடுத்துட்டாங்க. இப்போ தான் உட்காந்து கேட்டுட்டு இருக்குதாங்க மேடம், அதுக்குள்ளாச்சும் எனக்கு கிளம்புங்கன்னு சொல்கிறாங்க. ஸோ அதனால் வந்து நம்மளோட சோம்பேறித்தனத்தை கொஞ்சம் குறைச்சிக்கிட்டோன்னா அவங்களுக்கு எல்லாத்துக்கும் நம்ம கண்ணில் விரலை விட்டு ஆட்டிடலாம். நடக்க ஆரம்பிச்சோன்னு வச்சுக்கோங்க, சைக்கிள் யூஸ் பண்ணான்னு வச்சுக்கோங்க, டயபெட்டிஸ் இல்லை, ஒபிசிட்டி இல்லை, ஹார்ட் டிசீஸ் இல்லை, எதுவுமே கிடையாது. சந்தோஷமாக ஜாலியாக கதை பேசிக்கிட்டே நடந்து போகலாம். உங்கள் பியூட்டிஃபுல் கேம்பஸ் எவ்வளோ ஸ்பேஸ் இருக்குது, அதெல்லாம் ட்ரை பண்ணுங்கள். ஓகே. ஸோ கார்பன்கிறது ரொம்ப ரொம்ப மோசமான ஒன்று. ஸோ இப்போ எதனால கார்பன் ஃபுட் பிரிண்ட்டுன்னு சொல்கிறாங்க, கார்பன் கேப்சர்னு சொல்கிறாங்க அப்படின்னு பார்த்தா, ஏன் ஹைட்ரஜனை வந்து க்ளீன் எனர்ஜின்னு சொல்கிறாங்கன்னா, பெட்ரோல் எல்லாத்துலேயுமே கார்பன் இருக்குது, ஹைட்ரஜனில் H+ மட்டும்தான் இருக்குது, H2 மட்டும்தான் இருக்குது, நோ மோர் கார்பன். ஓகே. ஆக்டிவேட்டட் கார்பன் ஒன்று இருக்குது, எதை வேணாலும் பேர்ன் பண்ணுங்களேன், இட் வில் பிகம் அ ஆஷ். அதை கொஞ்சம் ஆக்டிவேட் பண்ணிங்கன்னா இட் வில் பிகம் ஆக்டிவேட்டட் கார்பன். ஆக்டிவேட்டட் கார்பனுக்கு உங்களுக்கு தேவையான ஒன்றே பார்த்தீங்கன்னா சர்ஃபேஸ் ஏரியா அப்படிங்கிறது என்னன்னா, இப்போ ஹனிகாம் பார்த்துருக்கீங்களா சார்? எனக்கு ஔவையார் ரொம்ப பிடிக்கும். எத்தனை பேருக்கு ஔவையார் தெரியுமா? ஔவையார், வெரி குட். ஔவையார் தெரிஞ்ச ஜென்ரேஷனாக இருக்கீங்க. எத்தனை பேருக்கு கண்ணதாசன் இருக்கும்? கண்ணதாசன் தெரியும், வெரி குட் சார். கண்ணதாசன் சயின்ஸும் டெக்னாலஜியையும் எவ்வளோ அழகாக தெரியுமா சார் சொல்லியிருக்காங்க? பறவையை கண்டான் விமானம் படைத்தான். பறவைங்கிறது சயின்ஸு, இட் இஸ் நேச்சர். அதை பார்த்து விமானம் ஃப்ளைட்டு கண்டுபிடிச்சது டெக்னாலஜி. பாயும் நதியினில் பாயும் மீன்களில் படகினை கண்டான். அவ்வளோ பெரிய கடல், அதில் இவ்வளோண்டு மீன் நீந்துது, அப்புறம் ஏன் நம்மளால் பண்ண முடியாதுன்னு சொல்லிட்டு கப்பல் படைச்சாங்க. எதிரொலி கேட்டான் வானொலி படைத்தான். ஒரு எக்கோவை வச்சு தான் ரேடியோ கண்டுபிடிச்சாங்க. ஸோ கண்ணதாசன் எவ்வளோ அழகாக சயின்ஸுக்கும் டெக்னாலஜிக்குமான ஒரு எக்ஸ்ப்ளனேஷன் கொடுத்துருக்காரு பாருங்கள். அதே மாதிரி தான் ஔவையார் வந்து ஒரு அழகான ஒரு அதியமானுக்கும் ஔவையாருக்கும் ஏதோ சண்டை, அது நமக்கு தேவையில்லை. அப்போ அழகான ஒன்று சொல்கிறார், வான்குருவின் கூடு வல்லரக்கு தேன் சிலந்தி அப்படின்னு சொல்லி ஒரு ஐம் சாரி இஃப் யூ எம் யூஸிங் தீஸ் கைண்ட் ஆஃப் திங்ஸ் உங்கள் இதில் சொல்லலாம்னு நினைக்கிறேன். ஸோ வான்குருவியின் கூடு, நீங்கள் எவ்வளோ பேர் இது இருப்பீங்க, சிவில் இன்ஜினியர்ஸ் இருப்பீங்க. தூக்கணாங்குருவி பார்த்துருக்கீங்களா? அவங்களோட கூடு பார்த்துருக்கீங்களா? 2 BHK 2 அறை இருக்குமா. ஒன்றில் வந்து முட்டை போட்டு குஞ்சு பொறிச்சு வைக்கிறதுக்கு, இன்னொன்று எஸ்கேப் ஆகிறதுக்கு. அதை வந்து எந்த சிவில் இன்ஜினியர்ஸாலும் ரெப்ளிகா பண்ண முடியாது. அவ்வளோ அழகாக வந்து அவ்வளோ ஸ்ட்ராங்காக தூக்கணாங்குருவி வந்து கூடு கட்டியிருக்கு. அதே மாதிரி தான் தேன் வந்து பார்த்தீங்கன்னா இட்ஸ் எ லிக்விட். மலைக்கு மேலே அகெயின்ஸ்ட் கிராவிட்டி ஒரு லிக்விடை எவ்வளோ அழகழகான சின்ன சின்ன அறைகளாக கொண்டு வந்து தேன் போய் வந்து தேனை வந்து வண்டு வந்து தேனி வந்து சேகரித்து வச்சுருக்கு. ஸோ அது மாதிரி தான் சர்ஃபேஸ் ஏரியாங்கிறது வந்து பார்த்திங்கன்னா உங்களுக்கு அந்த தேன் கூடு மாதிரி அயான்ஸ் வந்து அங்கே போய் உட்காந்து வெளியில் வர்றதுக்கு. ஓகே. ஸோ ஆக்டிவேட்டட் கார்பன் வந்து இட் கேன் பி ப்ரிப்பேர்ட் இன் எனி ஃபார்ம் ஆஃப் அ திங். பயோசோர்ஸாக இருக்கலாம், பயோமெட்டீரியல்ஸாக இருக்கலாம், இல்லை ஒரு சேராக இருக்கலாம், வேஸ்ட்டான எந்த பொருளாக இருக்கலாம், எதை வேணாலும் நீங்கள் வந்து ஆக்டிவேட்டட் கார்பன் தயாரிக்கலாம். நான் ஃபஸ்ட்டு ஆக்டிவேட்டட் கார்பன் எதில் பார்த்தீங்கன்னா வேஸ்ட் நியூஸ் பேப்பரில் எங்கள் வீட்லேருந்து தான் ஸ்டார்ட் பண்ணது. இன்ஸ்பிரேஷன் அப்படிங்கிறது வேறு எங்கேயோ வர்றது கிடையாது. ஒரு சயின்டிஸ்டோட ஜாபுங்கிறது வந்து அப்படியே A+B+C² சொல்கிறது கிடையாது. ஒரு கஷ்டமான விஷயத்தை எவ்வளோக்கு எவ்வளோ சிம்பிளாக சொல்கிறோமோ அதுதான் வந்து ஒரு சயின்டிஸ்டோட ஜாபுன்னு நான் நினைக்கிறேன். ஐ ஹோப் ஐ வில் ஆல்சோ டூயிங் த சேம் திங். ஸோ ஆக்டிவேட்டட் கார்பன் வந்து பேப்பரில் வந்து எப்படி தயாரிக்கிறாங்க அப்படிங்கிறது நீங்கள் கூகுள் பண்ணி பார்த்தீங்கன்னா தெரியும். ஆஃப் பண்ணிட்டாங்க, டைம் ஆயிடுச்சுன்ட்டுன்னு. Okay, activated carbon from newspaper தயாரிக்கலாம். One more interesting thing is camphor. நான் கோயிலுக்கு போனேன், காரைக்குடியில் இருக்கும்போது ஒரு கோயில் போகும்போது நம்ம கருவறையெல்லாம் ரொம்ப கருப்பாக இருந்தது. ஏன் இப்படி கருப்பாக இருக்குங்கிறப்ப சொன்னாங்க கேம்ஃபர் இஸ் ஒன்லி மெட்டீரியல் சாலிட்லேருந்து டைரெக்டாக கேஷியஸ் ஃபார்ம் ஆகுது, அதனால வந்து ஃபுல்லாக கருப்பாக இருக்குன்னாங்க. எதை கருப்பாக பார்த்தாலும் கருப்பு தான் எனக்கு பிடிச்ச கலர்னு எடுத்துகிட்டு வந்து உடனே அதை ப்ராசஸ் பண்ணி ஆக்டிவேட்டட் கார்பனாக மாற்றி அதில் கார்பன் எவ்வளோ இருக்குன்னு சொல்லி அதை வந்து சூப்பர் கெப்பாசிட்டர் மெட்டீரியலாக கண்டுபிடிச்சது. அந்த கார்பனில் பாருங்கள், அந்த கேம்ஃபர்லேருந்து வந்த ஆக்டிவேட்டட் காம்ஃபரில் அதுக்கு நானோ பீட்ஸாக ரொம்ப அழகழகான நெட்வொர்க்காக பியூட்டிஃபுல்லான ஒரு இது வந்தது. அதே போல் தான் ஆரஞ்சு தோலில் ஆரஞ்சு பீல் கோகோனட் ஷெல்லு இதுலெல்லாம் பார்த்திங்கன்னா ஆக்டிவேட்டட் கார்பன் நிறைய வந்து தயாரிச்சிட்ருக்காங்க. ஒன் மோர் திங் வந்து பார்த்திங்கன்னா இதில் சைனாவில் வந்து பார்த்திங்கன்னா ப்ரோட்டீன் கண்டென்ட்டுக்காக வந்து காளான் சாப்பிடுவாங்க, மஷ்ரூம். நம்ம என்ன பண்ணுறோம், மஷ்ரூம் வந்து அது ரொம்ப காஸ்ட்லி 65 ரூபா சொல்கிறாங்கன்னு சொல்லிட்டு நம்ம சாப்பிட மாட்டேங்கிறோம், நம்ம பிரியாணிக்கே போயிடுறோம். பட் மஷ்ரூம் வந்து பார்த்திங்கன்னா அங்கே வந்து டன்ஸ் அண்ட் டன்ஸ் ஆஃப் மஷ்ரூமை வந்து தயாரிக்கிறாங்க. ஸோ மஷ்ரூம் தயாரிக்கிறது எப்படின்னு பார்த்துருப்பீங்க, ஒரு மாய்ஸ்சர்டு அட்மாஸ்பியரில் ஒரு பேக்கேஜில் உள்ள சீடை போட்டு வளர்ப்பாங்க. நேத்திக்கு பேஞ்ச மழையில் இன்றைக்கி முளைச்ச காளாங்கிற மாதிரி அது முளைச்சி வரும். அதை கட் பண்ணி நம்ம சாப்பிட்டுட்டு மீதி என்ன பண்ணணும், செல்லோஸை தூக்கி வெளில வீசணும். அது பண்ணக்கூடாது, சைனாவில் பண்ணால் அடி விழும். அதை எடுத்து நாங்கள் என்ன பண்ணோம், அதை வந்து கார்பன் மெட்டீரியல், ஏன்னா எனி கைண்ட் ஆஃப் செல்லுலோஸ் மெட்டீரியல் நேச்சர் ஹேஸ் இட்ஸ் ஓன் ப்ராப்பர்ட்டி. ஒரு இலைக்கு ஒரு வித்தியாசம் இருக்குது. வாட்டர் ஹயாசன் கேள்விப்பட்டிருக்கீங்களா? ஆகாய தாமரை குளத்தில் இருக்கும், ஒரே ஒரு வேர் இருந்தால் போதும் சார், ஃபுல்லாக எல்லாத்தையும் ஆக்குபை பண்ணிடும். இட் ஷுட் பி எராடிகேட்டட். அதை எடுத்து ஆக்டிவேட்டட் கார்பனாக பண்ணோம். எது கண்ணில் பட்டாலும் சரி உடனே ஆக்டிவேட்டட் கார்பனாக பண்ணியாச்சு. ஸோ அதே மாதிரி தான் இந்த மஷ்ரூமை வந்து எடுத்துகிட்டு அந்த செல்லோசிக் மெட்டீரியலை ப்ராசஸ் பண்ணி ஆக்டிவேட்டட் கார்பன் ஆக்கி அதையும் ஃபியூயல் செல்ஸுக்குமே யூஸ் பண்ணி நான் பண்ணியிருக்கேன். ஸோ இந்த மாதிரி மெனி சேலஞ்சஸ் ஆர் தேர். இப்போ இருக்க ட்ரெண்டில் நீங்கள் 3 hours நீங்கள் ரெடியூஸ் பண்ணுறதுக்கு உங்களோட வேஸ்ட் டு எனர்ஜி, வேஸ்ட் டு வேல்யூபிள் திங்குக்கு இதுதான் ட்ரெண்டு. இப்போது ஆல்மோஸ்ட் எவ்ரி திங் ஹேஸ் ரீச் சேச்சுரேஷன், எல்லாமே வந்து ரீச் ஆகிடுச்சு. அதை எப்படி நம்ம ரெடியூஸ் பண்ணி ரீசைக்கிள் எல்லாமே மெட்டல்ஸ் எல்லாமே வந்து இப்போ எக்ஸ்ட்ராக்ட் பண்ணி வேஸ்ட்டு, இப்போ நீங்கள் ஒன்றுமே இல்லை, வேஸ்ட் பேட்டரியிலேருந்து நீங்கள் மெட்டல் எடுத்து பாருங்கள், யூ வில் பி கெட்டிங் so many projects. Okay, so with this thanking you all for your kind attention. If you have any queries, please you can ask me. The supercapacitor. சரி போல வரல, ஆஃப் ஆயிடுச்சா? ஓகே ஃபைன், அதான் டைம் ஆயிடுச்சுன்னு ஆஃப் பண்ணிட்டாங்க. நார்மலி இந்த ஸ்லைட்ஸை நான் யூஸ் பண்ணுறதே இல்லை சார், அது வந்து
இல்லை, அது ஓவர் ஹீட் ஆகிடுச்சு, வேறு ஒன்றும் இல்லை.
நான் யூஸ் பண்ணியா சார்?
நீங்கள் யூஸ் பண்ணல, அதுக்கும் நானோ டெக்னாலஜி தேவை. எனி கொஷன்ஸ் ஃப்ரம் த ஆடியன்ஸ்? அவங்க ஆரம்பத்திலே ரொம்ப என்டர்டெய்னிங் ஆடியன்ஸ்ன்னு சொன்னாங்க, பிரைட் ஆடியன்ஸ்ன்னு சொன்னாங்க. ஆனால் ஒரு கேள்வி கூட இல்லையே. I have one question, ma'am. See, we were talking about nanotechnology in sustainable, energy and all that. The latest green nanotechnology concept is coming up. But again, when we take green nanotechnology, wherever technology comes in, we need to look at certain aspects like ethics, right? And regulatory frameworks are there. And also safety. This மூணும் வந்து very particular to health. When we use nanotechnology, I think these things are very important. How your research on the various nanotechnology batteries which are being used for medical devices which are implanted, how this is being taken care of?
Correct, sir. That is what we are looking to the self-discharge. The battery, we are for medical applications, when you are making a battery, how it is a green technology அப்படின்னு கேட்குறாங்க. So that is true only. So when you are implanting a battery to our body, so we should make sure that the battery has no hazards. So lithium iodine which will not absorb, no water is there. எங்கெல்லாம் வாட்டர் இருக்கோ அங்கே தான் வந்து கரோஷன் இருக்கும். So we will look into the matter that water will be reduced, no water or low water technology. So that is how the green technology comes into battery in medical applications.
Thank you, ma'am. Thank you.
Every year, September 26th is open day to all over India of CSIR. So, உங்களோட நியர்பை செக்ரியாக இருக்கட்டும், காரைக்குடியாக இருக்கட்டும், சென்னையாக இருக்கட்டும், எங்கே வேணாலும் வந்து நீங்கள் எங்களோட டெக்னாலஜியை வந்து பார்க்கலாம். எவ்ரி இயர் September 26th. Just now we are completed. So, அதுக்குன்னு பர்டிகுலர் டைம் இருக்குது சார். ஸோ அந்த சில டெக்கோரம் சில ப்ரோட்டோகால்ஸ் எல்லாம் சில விஷயங்கள்லாம் நான் ஓப்பனாக சொல்ல முடியாது. அதெல்லாம் தான் பண்ணிட்டு சின்ஸ் வி ஆர் கமிங் ஃப்ரம் பேக் எங்களோட சம்பளம் இல்லைன்னா
Thank you, ma'am. Thank you.
Thank you, ma'am, for your nice presentation. Now I invite Professor B. Nanasekar, Director IE from Vinayaka Missions Research Foundation, deemed to be University, Salem, to honor the keynote speaker, Dr. D. Kalpana. I would like to call Professor Dr. B. Jaikar, Director Clinical Trials from VMRF DU, to honor the chairperson of the session, Professor Dr. P. Nanasekar, Director IIE of VMRF DU. Thank you, sir. Dear attendees, a tea has been arranged outside of the auditorium. You will be back within 10 minutes. Those who are having a presentation in this auditorium, you will be stay back here. If you are having a PPT presentation or you are having a presentation, you just hand it over to the auditorium. Dear attendees, those who are going to present the paper here, you come and hand it over your PPT. The session will begin after 10 minutes. No, ma'am, those who are allocated in this auditorium. Tea break முடிச்சிட்டு என்கிட்ட எடுத்து சார் PPT. Nice presentation. Tea சாப்பிட்டு half an hour தான் half an hour குள்ள
வாட்ஸ்அப் பண்ணிடுறீங்களா? successfully got a BA, and it's a bodybuilder only tail, and this how you have every medicine people. Thanks.
from dynamic and 30% cost. My dynamic being dope primary here cost production of mostly is made. First cost serious and drawing oil filter material and others. Malicious material extra process vessel. Cost is by duration service weight tax with the other from card option. Still issue particular and cost in the cost of it is 2 lakh every year. This is economic and back. Question is impossible to enter in it, but the burn I don't suffer a human body. It length and have insulated for a kind of occasion. So I come like oxygen, hydrogen, but muscle for it over. It is now since polymetry and the put this in poly this is for question is of and the chemical defense this is from a state of it is the end property. Now they will bring it back of to maintain cost rate. We have to practice from model of male use. Our inhibitor, how will the inhibitor remove the cost rate and even efficiency? We have to take that based on the and point body of surface. Inhibition is very harder to say. Also very different for function. He does arms and rod flips the surface after time you don't stability and so time efficiency. Higher size of the inhibitor maximum efficiency 8.3 hours. It becomes stable on the others. If it rise down with the cost rate is increased, inhibition efficiency will come increase. It has below productive on the surface. Increasing in inhibition efficiency outside of nothing. They will want to output make under metal space strongly. Scope make it is certainly able to evaluate the multiple in the adding medium. Discussing this structural these techniques are used these days to find the data turn the qualification. This while evaluate the errors. Now our meter fixed heat control is high evaluation. Even speed and squeeze. Technology it's bank this farmer word our product it's around
now you doctor see that real to have mind versus okay that is the we have to get some the milk you have to hardly interest. So color that is so why matter. Why was the bank of bala? I mean nine. I mean where that was necessary. The right is up you like usually done to be full for practice cancers. Okay, so check whether it is necessary. Okay, will carry over production. All the best.
from education college. Topics of my ambitious aspects for marks. It picks out chemical application and materials that for 8 of the artists using our program. So, as 8 of the artists with a chronic inflamed disorder caused by the sand central jet layer, a text lip layer. So, what is the type of batters that character will be of course intention. So, the radical is 8 marks include cytochrome signal for the cascade. So, the size and height for the keys. I found the third of mobs. That's where I sang it having here. So, I can our mother function rule of the flame and other property modification. So, is a offer the outside of the target. So, increase and flatless. So, upcoming tool use are used for situation quantification of the whole project. So, in the early load models like molecular shippers are small, molecular, and following proposals. So, it's a whole model where I continue and started green and racking out on my head. So, chemical application here because we have over that a rule is I have rule that food which is can read beside the room. So, the very chemical application battery she will do display and she's normal. QVR and this is QVR cell and this is the molecule. Added properties in probably also use hard running and added properties which seen per appear. And test nanomaterials nanomaterials used to deliver for various nanomaterial or PLJ is used to develop this. So these are results of nanomaterial achieved 20% increase in dermal fusion. Thank you.
You would love to be 30 grades. So your results is for them?
I first prepare and other data and
it means that delayed survey.
It
is a particular next. Madam, you can't put it.
Good evening, on the resident here. Same sir, name is Salem. And it's subject to literally pharmaceutical content system using IPC and LTS. What is the extract niches? What is the extract article? Example means out the rod. Seed of the patient speak to anti-rod and the ability to with treatments to size of ideas, lecturing and analytical things, actually alliums. This is a retrieving all aim at to level and value in achieving LC and LTMs make with the identification of step and nature compound, fortunately tech resist, entering product city integrity campaigns, up to high potential steps to avoid relatives to see impact patient to sizes is approach or mentality analytical characters, affects simplification, medical development validation, it necessary combination, it is the preparing of samples, double doses here natural transferable, it is preparation by and Nanomaterials, butter split and standing, butter alternative, effect this has to ratio, IPC use butter, but one plus incentive value here, TRC 18, column we are using, market of speaking, using butter active 0 7 shoot, LD ignition, black for house 8, we are using, what say, fox slim time we are using here. IDS in LTM, Sanal Farmit Kani, Happy Sick Madam, yet the kinds of traffic problems, very of the last is the bishop, and even be staff, and yet analysis, the to speak, strain of papa and special nation using, I will of Matram of Milorium, satellite, posting to Matram of I guys, all I region. Later, get my preparation and sharp 100, but I am the it may loading this bit. Then take my try and my special relation, pressure of 2 million this fixed air for more. We here present free and as you can see, we are doing then we over here present. You are next space, some space, and sorry, the program, thermally the only projects on to pilot program, and then you could here and say, to make this, then it will times and then direct and they would the stress, pressure, some attention, the still much details, and I got to say, the product and for jobs in England, and I got salary, Mr. Application, passage, and we are doing project based on all the departments. We are give 70 broad commission for the only this project. Thank you.
Actually, you have various pharmaceutical companies all over. Like you have also HCL.
Yes, and what's your
why you have to
one person?
I'm doing chemistry part percent. Okay.
Thank you.
Good evening, my name is Mr. Has started from an functional graphics, reinforced the epoch in the medium except for reduce reduce and the the view of the and shift graphics and values different reduced and was and structure and viewers resort features aggregate and same of the image and release in the fabric size and main groups and rectangle for blank rectangle and so what model cannot this was drawn to OC value of image period. In this we have seen that the radio refracted value was less compared to that of the land. We would state that the radio geos have protective less active surfaces stated at after image of 6 days dependent solution and this is Photochemistry production graph and insufficiently the IR value was reduced and CR value was increased. And PF percentage was for our use reflect was 99.6% after 6 days of mission, where for remaining percentage the value was increased to 80 and 30 increase the real graphics not good particular after the remember. As well as compared to the R value was for reduced granite was here in initial stage reduced, whereas the percentage reduced. But after extending the reduced granite still has to run the same value, whereas the on the less amount of values. This case is the aspect of the connect for the aspect images reduced granite best scoring up to 10 days of function.
You have started made in cities. New state Or is the event? Where you have for normal.
Measured I have repeated tips as well as tips we expose the line for types so the loss will be made no all the risks.
I'm sure in this project third part. And my topic on it is tackle having activity all of the functions. My YouTube channel and of Slata. And my these are Windows when I want to garden some tournament to pair in all graphics. I actually all my proper value and for doing content to chemicals access on design with fingerprint analysis. Like final and for simple and was done by organs also you have value on 5M screen results that did and then the content doing the pictures it was the at 100 because with those as now key condition and these calculations done with example this we as the right can activity next activity and that's which can be calling the won't carry education element method and local under 100 and is a result and it is not when which is until that is active portion or to find the method element assist you are in the fire number and this is also reducing the damage and it has been sensitive.
The final result confirmed the item compound is with the afternoon. The is the CDR, the graph, maybe the 5 type, and the formation are response to 18. So these are the results for my project and for the to build this project. For an anti-diabetic potential powder and for a rich candidate of alpha and alpha say with unseen metabolism and giving strap to the animals and change what was it in the assistant or enhanced standards to and I would know stage of my particular research. Sir, actually, this was it is my here, so I wanted what that structure has. No, sir, like they were using that, sir. It was a section with all these and numbers get that, sir. So I've heard all these bull atmosphere in such regularly and performance published. And then what tell the students, sir? So I had what this other also the basic. Yes, I've got activity at maximum. So I really tried to deal with alpha activity control quite a moment. Yes, so I have a process. So for to develop that as a thanks so much.
Dear participant, can't like to get I must. I invite the system for computer science, G. Today the conference is going to an end, and tomorrow the conference will be continued tomorrow. Thank you.